School of Arts, Communication and Languages, School of Social Sciences and Humanities, School of Life, uh, School of Agriculture and Allied Sciences, School of Life Sciences and School of Engineering and Technology of Himati Nandan Bhaguna Kadwar University, Srinagar.
Now, I would like to call Mr. Sanjeev Sharma, Department of Physics, Scholar, to invite the chairperson.
Thank you so much. Good morning, everyone. I hope your stay was comfortable and cozy. Now, to start our technical session, I would like to invite Dr. Yushi Dhumka sir and Tushar Kandari sir to chair this session, technical session.
Good evening, everyone. So before breakfast, we have two invited talks. The first talk is by Dr. Vinay Kumar. So this Dr. Vinay Kumar is working in US. He has done his Master of Science in Physics from IIT Roorkee, Master of Technology in Networking from Pune University, and PhD from also in Pune University. Most of his research work is basically involved around the Indian summer monsoon, rainfall prediction, etc. And the aerosol and organizational conduction role of monsoon heat and artificial layers. So like this is the MGS research study on from Dalwara from Dalwara. At present, he is acting faculty of physics of Texas University. You don't mind, right? So I invite Vinay Kumar to present his talk. Vinay, so he has recorded talk. So basically, talk, advertising of this talk is like Indo and Portland.
Good morning to all of you. It is 11 p.m. Western. I am looking for a faculty in Department of Physics and Geophysics, Texas University, USA. I did this work with a master program is project characteristics in Sahab University, Saudi Arabia, and history acquisition in America, USA. And that's about that. This student talking as a complete sporting advertisement. I am also from India and UP district resort, so I am well aware about this program that other events basically. This paper is already published in year 2021. And this one is already publicized by Dr. Rajivan Nayak through his Twitter account, and I also put it to scientific community as well. So let us start from the fundamental of fog. So fog is nothing but the cloud at the surface. The fog forms when humid air near the ground cools, blows deep. The dew point is zero, where saturation reaches 100%. At that point, the air cannot hold more water in the form of gas with water vapor. So, this is for the small turbulence. And those things in the atmosphere, they reduce the visibility less than 1%, sometimes less meter. In this research work, I will consider the dynamic term and thermodynamical process that are responsible for the formation of our IGP. On the background of the four our intervention plan, we know that IGP experiences widespread and depth radiation form for several days, around 1 month, of which December to mid-January, around 30 days. So these are the photos I've taken from NASA website. So you can see the deep flow, which is over in UP, Haryana, Punjab, and extended up to the Pakistan area. And you see on Bihar and West Bengal, you can see age. So age and form both reduces visibility, but thermodynamically they are different. In case of form, there is a formation of saturation, and saturation can be attained over dew point temperature. With reducing the temperature of the boundary layer or surface layer, or you can say four layer as well. Or just pump more and more moisture to the air so that it can achieve the saturation level. However, fog results from a high concentration of aerosol in the atmosphere. We all know this. So in winter, IGP has low surface temperature, yes, in winter time, heavy subsidence and a cloud-free atmosphere, and light winds and high moisture for IGP. These are the conditions that fog starts to form. Another thing, radiation fog requires calm air, very low air, low wind, as compared to adversarial fog that is found in Golden Gate in USA, that is quite famous in San Francisco. There are four types of fogs, radiation fog, so IGP, and Walking Valley in California as well. And the P is the adversarial fog is occurs when warm and moist air move over a colder region. And the steam fog, which occur on the day, and in cold air, just walk or you can say enter over the lake. And the P is the valley fog, which generally found in the all hilly area, China, India, and Nepal. So the key points of fog formation, you could find three papers. Data, which I think 70, Brown and Broad, 1976, and Roden, 1966. Which all are 50 to 100 years old papers, which will explain about the radiation fog and formation. Basically, for the fog, as I mentioned in my previous slide, we need so many variables, those are critical, and their values also very critical for the fog. So fog does not form due to relative cooling of the ground alone. It requires very more like turbulent eddy and different temperatures, but close to saturation. And take the layer is mixed adiabatically with the stable boundary layer. And that if the ground cools, but the adjacent area does not form. So it requires a turbulent mixing of heat, water vapor between the cooling surface and air adjacent. What is the form or boundary layer? And are critical processes for fog formation. So fog formation over IGP is a delicate balance of dynamics and thermodynamics of radiative fog in the IG and the critical role of turbulent mixing agent. December and January. And we have taken the data set which are set from NARA-12 analysis from NASA. So you can see in figure A, the green boundary shows the IGP region, which includes Punjab, Haryana, UP, and Bihar. Let's show the vertical pressure velocity at 90 degrees. So red color or vertical velocity shows the downward velocity, and blue shows the upward velocity. So most of the IGP region is really under the influence of subsidence. So number of conditions which is fulfilling our IGP. Thus, means due to this subsidence, there is no formation of any ground cover. B is the vertical profile of vertical pressure velocity, omega, and water vapor. So the average over IGP region, which is shown in the figure A. So you see in winter time, the average water vapor is 3.5 grams per kg. You can compare with the monsoon time. The monsoon time on IGP region, the average one is 15 grams per kg. So there is no water vapor, but it is sufficient for the formation of foam for IGP. Then you see the vertical pressure velocity for December and January, which is around 1 millibar per hour. That is quite necessary component for the formation of foam over IGP. Is the sufficient in IGP? Here we show the mean annual vertical pressure velocity as a function of altitude and pressure levels for all the months. We can see that during monsoon season we have the vertical velocity which is upward. Other than that, most in all the months it is downward. Vertical velocity is subsidence. But interestingly, you can see here at 500 millibar, this is the spirit of troposphere. There is showing the western distant belt. On this slide, we show many related variables for the formation of foam in the boundary layer. The first one is showing the four variables: vertical velocity and wind speed, recharging number, and surface temperature. One more thing I would like to tell for all other panels in this slide, that blue color number shows the mean of that particular variable, and the right side of each panel, the red color, shows the mean of that variable after the change point. So change point we got in our research work around 1996-97 or around 2003, few of the cases. And you see one more number which is maroon, which shows the percentage change in these variables. So the first, that was the first one. So this is the standard emission of the variables just to compare. You can see from the change point of this vertical blue line in A, all the variables these are changing from the time of 1996 and 97. We just go to B, high cloud fractions are decreasing, is goes to C, LWR, long wave radiations are increasing. Those show that in the middle and upper troposphere, the cloud surfaces are decreasing. That's why OLR is increasing. That again shows that western disturbance are decreasing. And another is charging number. That has increased. If the charging number is more than 0, it shows the stable boundary layer. And for 4 we stable boundary layer. Now converting activity. Friction velocity and exchange coefficients of heat are reducing. These are the variables for the stable boundary layer. On this slide, we have the normalized boundary layer variable with the earlier variable to the four different regions in IGP. IGP, Punjab, Haryana, UP, and Bihar. With just it will show that from the time of change of point that United States in all that vertical line, you can see these variables changing in their sign. For sufficient, one station number, surface wind speed, surface temperature, and operation humidity. Again, some more variables to let you know about the condition of boundary layer or form layer. So, exchange coefficient of momentum, buoyancy, speed, exchange coefficient of moisture, vertical pressure velocity, surface wind speed, all are decreasing. And the first is reported at 10%, 10%, 28%, 31%, and this is surface wind speed 3.7%. The last surface water vapor it is increasing by 13% in boundary layer. And these are the required conditions and it is several conditions for the formation of foam. We analyze really so many variables, those were relevant to the foam formation in ICP. On this slide, these are the data sets from National Climate Data Center and JDC. And then this called surface observations. So we plot these surface observations at Surface Airport in Delhi. So you see the visibility is keep on decreasing up to 2020 and relative humidity is keep on increasing on this station. While fishing ratio is keep on increasing, so that and dew point is keep on increasing. While surface temperature is showing increasing trend or just it is constant. What more interesting point? The operation and relationship and surface. See from here you can see they are showing a relationship of 0.8 to 5. So evaporation is increasing because of turbulent eddies. They take the moisture from surface to the top of the fog layer. So here on this slide we are just showing some atmospheric variables of the boundary layer for the fog formation. So this is the period height in the panel. It has 7 degrees after 1996 from the change point 20%. It seems like the fog formation is now confined to a smaller box, like a smaller room or something like that, or boundary layer. The other A and B are the cloud fraction low and mid. This shows that the formation of vector disturbance has decreased over the IGP region. Another is F1, which shows AOD energy has decreased by 205% of IGP. And this is really important one. Rainfall due to western disturbance and surface temperature in IGP. So rainfall from western disturbance has decreased almost by 17% over IGP. So these blue dots line is the average of the rainfall before 1992, and red dot line shows the mean of western disturbance rainfall after the change point. Additional surface temperature also decreased. And here is shown with these clouds, the surface temperature and western disturbance rainfall. You can see they are not overlapping. So at in the present years, the surface temperature decrease and rainfall also decrease. You can see same with these tall curves as well. These are the data sets of irrigation of EPW Research Foundation of Bombay. And in the figure A, you can see that cloud-like irrigated area in hectares is increasing. And the vertical bar is gray color from the change point. So to there, they keep on changing and these are quite a peak. And in power consumption,
Your time is up.
the power consumption will keep on increasing. Initially quite fast, it has become almost research in these two schematic diagram before some people who do research the boundary layer deep subsidence and traded in food. A sudden decrease in and harsh cooling and has altered dynamics, thermodynamics, and increased irrigation.
Thank you.
Is there any question from audience?
Any questions, audience?
Dr. Bidaji,
Hello.
it's a very important issue you have discussed about. You have shown that before 1997 and after 1997, there is a drastic change in the precipitation due to western disturbances. Is it that? Sure.
Hello, are you hearing?
इससे आएगी वहाँ पे बॉक्स लगी वहाँ पे
Hello, Vinay sir, can you hear us? Hello. 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 Hello.
Hello.
Thank you, Vinay.
Hello. 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 Thank you so much, sir. Thank you so much, sir. Now we are moving for next presentation.
Yeah, thank you. So next talk is by Professor Satish. Basically, I would like to invite Professor Satish to present it. So basically, I will in brief introduction. Basically, Professor Satish is the fellow of Indian Geographical Union and he is fellow of Ecological Society. Presently, Dr. Placement, head of the Department of Basic and Social Science. So over over the 30 years of research, he has 30 years research experience. More than 60 research papers he has published in international and national reputed journals. So I would like to invite Professor Sati to present this talk.
Hello.
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 Hello. Can you hear me? There is an announcement regarding the poster presentation. You can display your posters in the first floor, the corridor. Okay. There are some. We have put some
Studies.
standees. You can display your posters there. Fine.
I'm not good. So actually, this my presentation is I'm not working exactly on the several change, but I will some idea the recent trends, recent influences of various aspects, various dimensions of climate change, and most of the studies will be from different authors, different scientists. मैं ऐसे ही बोलता हूँ तो सुनाई देता है? Actually, this is these are some recent data to 2020, right from 1968. There is consistent measurement of the temperature, including the events, the ocean temperature. You can know that there is a so it shows that yes, there is a consistent rise in temperature, it's a rise in temperature, and so the CO2 concentration also. It is the measurement, the consistent observations of the Charles David Keeling. Till 2021, it is 415.52 ppm. CO2 is consistently the concentration of the CO2 in atmosphere it is rising. Okay. आगे बढ़ाओ. Now, one major paper published. This came in the Nature Geoscience, which shows that due to climate change, due to global warming, there tremendous melting of the glaciers in the mountain high Asia, and due to that, the hydropower projects in mountain high Asia, including Himalaya, they are in a very serious threat. And because for the three reasons, one is due to melting. Very soon the situation is coming in near future. Latest by 2050 that the discharge in the rivers will be drastically reduced. One thing. The second thing is that due to melting or recession of the glaciers, they leave the loose material, what we call the glacial sediments or moraines, in the linear pattern in the valleys, and in the extreme events of the rains, that material, that sediment will mobilize towards downward, and because of that, dams will be, the security, the safety of the dams will be in the state. The third thing is that because of the recession of the glaciers, the slopes from both the sides of the valleys, they will be reactivated, and because of that, huge landslide activities will be there. Because of these three reasons, the dams in the high mountain Asia are in the deep threat. This is the another inference by some studies, and I have Nature Geoscience. This is published. Another thing is that yes, that I have already discussed this point. Now, the another point is a very important study. Some 615 rivers, the sediment pattern of the some 615 rivers were measured globally, and it has been found that in the southern hemisphere and northern hemisphere there is a drastic change in the sedimentation pattern in the rivers, in the flux in the ocean by the rivers. In the southern hemisphere, there is a drastic increase in the sedimentation by 41% since 1981. There is an increase of 41% sedimentation in the southern rivers of the southern hemisphere, which are bringing the sediment into the ocean. The increase is 41%. While in the northern hemisphere, it is drastic reduction in the sediment flux in the ocean in the northern hemisphere, and they inferred this because of the dams mushroomed in the northern hemisphere, in the rivers of the northern hemisphere. So this model they have published. Now, what does it mean? Though the erosion rate is increasing, and that too in the northern hemisphere, because of the dams, the sediments are locked in the intermountain basins in the dams in the northern hemisphere. Because of that, the connection to the plains or in the downward is disconnected. The river connection is disconnected. The ecosystem services are disconnected. It's a very important study. Why? What is the relevance in the light of the climate change? What is the relevance of this study? I will tell you. One more study. Paul Watson published in 2022 in Science. It says that the increase of the methane in the atmosphere since 2006 till today, the increase of the concentration of the methane has raised up to 7%. 7% methane is raised, and why it is so, they don't know. And methane is much more dangerous than the carbon dioxide. The only thing is that methane, the life of the methane is about 15 to 16 years. Or carbon dioxide has a long sustainability. But the very speedy increase in the concentration of the methane is a very alarming situation. And they could not find any relevant cause of this increase. This was also found in during the COVID period, when there was no emission of methane as such from the vehicles and all these things. But even then, there was a drastic increase in that. Why that? They found the possible explanation of this was that due to climate change, there is an increase in the precipitation in the tropical regions, and because of that, they inferred that the number and the area of the wetlands are increased substantially. And because of that, because there is a bacteria which emits the methane in the wetlands. This was the influence. My question is that you have seen that the dams, the effect of the dams in the sedimentation, the effects of the dams in the sedimentation is a very drastic. And you are saying that because of the increase in the precipitation, the methane emission is increased. Why you are not considering the dams? Because such a huge reservoir, they will produce more methane. This is a question which is not answered yet. The another these are the things. Now let us sum this all. Himalaya, the Earth's most important and vulnerable water tower, is warming at a rate is double the global average. Global average is 0.16 degree per decade, and the rate of the temperature increase in the Himalaya is 0.32 degree, just double of that. And Himalaya is one of the most fragile, most sensitive terrains. So see you can think of the disaster ahead because of this climate, this temperature increase. The evolution of precipitation reveals an increasing trend over the Himalaya during summer associated with an increase in wet extremes and daily intensity and a decrease in the number of the rainy days. What does it mean? It means that number of rainy days are the number is decreasing and the number of heavy precipitation days of heavy precipitations are increasing. That is another big thing which can cause havoc in the Himalayan terrain, where fresh flood is the trend of the fresh flood is increasing drastically. Almost all the 15,000 glaciers are shrinking. This is everybody knows, except this Karakoram anomaly. In Karakoram region, there are some glaciers which are showing the advance. So, but there are studies going on, but there is a controversy over that. Fragility of the terrain is increasing trend of climatic extreme. This I have already told. Now, this is another paper which is published in 2021, which shows that since for last 20 years, from 2000 to 2019, there is a ice cover loss for 20 years. See in the Himalayan region, it is 6.9% of the glacial cover is we have lost in 20 years. And somewhere it is for 26 in northern Canada, it is 26.5. In Greenland, it is 15 point something. So there is an alarming rate of glacial cover reduction in globally, which is very this global assessment is here, and it's a major paper published in 2021. Now, I have already told you that why the Himalaya is vulnerable. The most puzzling fact which is coming right ahead is that this linear distribution of loose sediments because of the glacial recession in higher Himalayan region, the huge amount of the sediments in loose form is there in the valley, which is mobilized due to heavy precipitation. And it is the big disaster for the dams in 2021. In the 7th February 2021, there was a flash flood in a small stream of the of Dholi Ganga, and due to that, two hydropower projects were scrapped out completely because of this loose material. In 2013 disaster of Kedarnath, the major loss occurred because of the mobilization of this loose sediment in the upper region. So, which is primary thing of concern is these linear loose sediments which are going mobilized because of the heavy precipitation. The number of days of heavy precipitation are increasing. Events of heavy precipitations are increasing. Because of that, this situation is quite alarming for the Himalaya. So, the planners should take this into consideration, and in the higher Himalayan regions, actually, in the higher Himalayan regions, the dams should be avoided. This was an assessment made by us. These this loose sediments in the Bhagirathi, 27 square kilometers is a covered area of that loose sediment. In Mandakini, it is 26 square kilometers. In Dholi Ganga, it is 34 square kilometers. Likewise, this was the assessment made by us. We have seen that what are the consequences. We have seen some consequences of this increasing events of flash floods in the dams, particularly in the dams of the Bhagirathi Valley, and we found that there are multi cases of the damage due to these dams. Due to drawdown effect, all the slopes are mobilizing downwards. because of these dams. Because of the events of the flash floods, the siltation rate in the dams is very, very high. It is much more higher than the expected one. Next. And one thing is that I want to show to Alok. Alok, you people are working on the aerosol. In this study shows that due to reduction in the aerosol percentage in the atmosphere because of efficient technology used in automobiles, there is a cleaner atmosphere in Europe, and because of that, global warming is increasing, in fact, not decreasing. So, aerosol cleanly reduction in the aerosol percentage is another problem. If there is a continuous emission increase in the emission of the CO2, but the aerosol is decreasing, that is uh, enhancing boosting the global warming, not reducing. This is also published in Science.
Professor, please, you have only 3 minutes.
3 minutes more, I'm going to close it. Sir. Thank you.
Okay.
Thank you. More now, this all we have already told, and these are some possible effects on the biodiversity. We have published this paper in 2013 in Climate Change, Journal of Climate Change, and this is a compilation of the effects. This is not our study actually. Based on the several studies, we have compiled this. The upward migration of the species because of the increase in the temperature, the upward migration of the species will occur, and it is a continuous upward migration of the species. At one point of time, when there is a high top, the already species that is growing at the top, where it will go? The the species which is growing in the lower altitude, they will move upward, and the species at the top will be vanished, will be extinct. These are the things. And some recent publications are, it's a new trend. People are thinking of the traditional systems. People thinking of the change in the food system prevailing in the globally. They are advocating for the traditional food system rather than this modern food system of non-veg and growing paddy, because that is also contributing in the climate change. This is also published in Science. And next, finally, nature-based solution. Scientists are now they are advocating for the traditional way of living. That is one of the major things published in Science itself. These are things what the globally the researches are oriented. That was a brief talk on that. Thank you very much.
Thank you, Professor, for a nice talk. So, any questions?
ये बात भी बताता है। ये पेपर ये बात भी बताता है कि जितने डैम, एक तो हिमालय में बहुत सारे डैम बन चुके चारों तरफ। वो कहता है कि 5 गीगावाट के कैपेसिटी के डैम्स पाइपलाइन में हैं, 3.5 के करीब बन चुके हैं। लेकिन जो भी अब नेक्स्ट डैम बन रहे हैं वो सारे के सारे हायर हिमालयन रीजन्स में बन रहे हैं, और हायर हिमालयन रीजन्स बिकॉज ऑफ दिस लूज सेडिमेंट फ्लक्स दैट इज क्वाइट वल्नरेबल। एक बात तो यह है कि हायर रीचेज में बारिश की टेंडेंसी बढ़ रही है। ये पहले नहीं देखा था। केदारनाथ में टॉरेंशियल रेन पहले नहीं होती थी, और ये आईपीसीसी की रिपोर्ट भी बताती है कि ये ट्रेंड बढ़ेगा, हायर रीचेज में टॉरेंशियल रेन्स आएंगी, क्योंकि वो कहते हैं, कुछ साइंटिस्ट बिलीव करते हैं कि ये हायर रीचेज में होने लग गया है कंडेंसेशन, एल्टीट्यूड बढ़ गया है, कंडेंसेशन होने का एल्टीट्यूड बढ़ गया है। उसकी वजह से जहां ज्यादा बारिश नहीं होती थी इनर हिमालयन रीजन में वहां भी होने लगी। इसका मतलब मोबिलाइजेशन ऑफ द सेडिमेंट विल बी स्पीड अप, और उसकी मात्रा बढ़ेगी। इसकी वजह से ये सारे के सारे डैम 2021 का मैं एग्जांपल देता हूं कि वहां जाके जब 200 लोग मर गए, डैम डैमेज हो गया, 3 बार हो गए, वो अंडर कंस्ट्रक्शन है। फिर उन्होंने फिर कहा कि इसका मतलब ये नहीं होना चाहिए कि ये डैम को रोक दिया जाए, इसका फायदा इस तरह से नहीं उठाना चाहिए इन्वायरमेंटलिस्ट को। हमने कहा हम ज्यादा चीज तो नहीं बोलते, लेकिन एक बात जरूर कहता हूँ, मेरे एक्सपीरियंस, ये जो तपोवन हाइड्रो पावर प्रोजेक्ट है, ये अंडर कंस्ट्रक्शन के दौरान ही 3 बार बुरी तरह से डैमेज हो गया, 100 से ऊपर लोग मर गए। मैंने कहा आप, मुझे जो फ्रीक्वेंसी आ रही है इस पे डैमेज होने की, हर तीसरे चौथे साल डैमेज हो, आप कभी बना नहीं पाओगे, और बन गए तो देयर विल बी डिजास्टर फॉर द डाउनस्ट्रीम पीपल। अब ये तो है ही है, जहां जहां उनको लगता है कि कई चीजें हैं इसमें, तो बड़े इश्यूज हैं।
Anyway, other question?
एक और क्वेश्चन है, ये जो रेंज का पैटर्न हो रहा है ना, चेंज हो रहा है, वो कहीं ना कहीं
किसी को मतलब क्लाइमेट चेंज का अवश्यंभावी दुष्परिणाम है टेम्पोरल और स्पेशियल डिस्ट्रीब्यूशन ऑफ रेन। फ्रीक्वेंसी ऑफ torrential rain events will be increased, number of dry days will be increased। हो सकता है कि एनुअल एवरेज 100 सेंटीमीटर श्रीनगर में है तो वो 100 ही रहे, लेकिन वो 100 सेंटीमीटर रेन पहले 120 दिन में होती थी, अब 90 दिन में होती है। तो और वो इसका मतलब टॉरेंशियल रेन्स की इवेंट बढ़ रही है, क्लाउड बस्ट की इवेंट्स बढ़ रही है, वो डिजास्टर्स होगा, उसकी वो रेंज ज्यादा फायदे की नहीं। ये सारी चीजें, और जहां पहले नहीं होती थी वहां भी, मैं कह रहा हूं केदारनाथ में होगी, और जब नहीं होती थी, मॉनसून आता है 20-25 जून में, वो 16-17 जून को आ गया। इस समय अक्टूबर में, पिछले साल अक्टूबर में, 2010 में सितंबर में, थर्ड वीक में। तो स्पेशियल एंड टेम्पोरल डिस्ट्रीब्यूशन ऑफ रेन्स एंड फ्रीक्वेंसी ऑफ टॉरेंशियल रेन्स विल बी इंक्रीज्ड।
Let us thank. Yes. Okay. Yes. Yes.
Yeah. No, it's a, I'm not working on the emission of, but it's a global fact that dams and wetlands are emitting methane because of the bacterial action. It is there. It is textbook case. No controversy about it.
So let's thank Professor Sati. So now I would like to request Professor Padhyay to present a moment to Professor Sati. So now we will have breakfast for half an hour. So we will collect here after half an hour.
Poster has already displayed the type of portion of this building. Also take it out.
टॉपिक में करेक्शन करा गए टॉपिक का ही साफ रखा था आगे हाँ ब्रेकफास्ट कर लिया तुमने करो ऑनलाइन वाला ग्रुप में भेज दो यार एक लिंक
ऑनलाइन यूट्यूब वाला
हाँ यूट्यूब वाला नहीं गूगल मीट वाला यूट्यूब तो सर चालू हुआ प्रोग्राम
यूट्यूब पे भी जा रहा है वैसे ऑनलाइन जा रहा है
यूट्यूब जा रहा है हाँ तो यूट्यूब वाला लिंक देना ग्रुप में यूट्यूब पे भेज दो और गूगल मीट पे भेज दो
सर मेरा अभी उसमें मैकेनिकल
instrumentation. Today I'm going to present few measuring techniques which are very necessary for measuring aerosols and air quality. Along with me, my colleague Sanjeev is also here. He is going to take the last part of the presentation. So my talk of the presentation is on complete solution for ultrafine particle monitoring as per the same standard, and also a new hyperlocal sensor which we launched recently for real-time air quality monitoring. Okay. Can you So my outline of the presentation will be briefly introduce PSI and few slides on atmospheric aerosols and tools for aerosol characterization and then SMPS, which I talked about, and also blue sky sensor. So TSI is a 60 years old company. We are into real-time aerosol monitoring, so providing solutions. And if you look at our complete solutions, or part of the solutions for the air quality, we have solutions for indoor and outdoor air quality monitoring in real time, and we also have a real-time engine exhaust emissions, and we have also a high research grade equipment for the aerosol research, and also we have some ambient monitoring solutions. So the inverted graph before you have been experienced what is actually atmospheric aerosols. There are a wide range of sources and sources for these aerosols. For example, if you look at anthropogenic aerosol sources to biogenic aerosol sources, secondary organic aerosols to primary organic aerosols, there are different types of aerosols available in this atmosphere. So they are all making our life very complex. Some of the aerosols are very useful for cloud condensation, ice nucleation, but some are very vulnerable for the air quality. All these are, we are facing, these are all directly affecting our atmospheric air quality and health. Okay, so if you look at the effect of the aerosols on human health, the particles which are below 1 micron or 2.5 micron, they are going inside our lungs, especially the particles which are below 100 nanometers, which we call it as ultrafine particles. They go even very deep into our lungs, and then they will penetrate with our blood cells. And you see in recent years, there are high number of heart attacks in the cities, major metropolitan cities, which is one of the major causes is air pollution. So for that, if you want to do anything related to air quality or aerosols research, you need a reliable equipment. So from this chart is from the publication of David Louis Puig, is one of the renowned scientists in aerosol science and technology. So in this chart, it was clearly mentioned what are the techniques available for the to measure different parameters of the aerosols, physical parameter of the aerosols especially. I'm talking about physical parameters only because in aerosol research, you need to know size, number, and mass of the aerosols most importantly. So to measure size, mass, number, there are direct methods and indirect methods. Direct methods are the methods which you don't assume anything. You can measure directly the mass or number or size of the particle. In the indirect methods, you will have some assumptions and then you will get some results, okay, based on the calculations. So, so I mentioned here PNPS PD, that means particulate mass, particulate number, particulate size distribution. These are the three important parameters which you need to know you need to when you want to characterize the aerosols, you need to know these parameters. So if you look at this diagram, this is one of the beautiful diagrams, which is the upper portion is for the number versus size, and the bottom is for mass versus size. So you can see the number of particles which are contributing in the atmosphere or in the ambient, the number of particles will be more, whereas those mass contribution will be very minimal. So people who are studying number and size, they always look from the beginning, from the 1 nanometer to 10 micron, 20 micron. People who are measuring mass, because they cannot measure the mass of the nanoparticles very easily, they always look for PM 2.5, PM 10 range, which is upper limit, upper size range of the ambient aerosols. and those number contribution will be very, very less. Because of the gravity, the particles will settle down on the ground. Okay? So here you have to choose what you want to measure. You want to measure number or size or particle size distribution. Based on the objective of your research, you have to decide which equipment you want to select. Because there is no equipment that can measure all parameters from smaller range to bigger range, size range in sense. Okay? So TSI is providing from 1 nanometer up to 20 microns of real-time aerosol measurements. So here we see one of the examples of the nanoscan, which is called nano scanning mobility particle sizer, many version of scanning mobility particle sizer, and optical particle sizer, which the combination of these two equipment can measure from 10 nanometer up to 10 microns. Okay, so there is other equipment, so which is called scanning mobility particle sizer. This is a gold standard equipment for the nanoparticle, ultrafine particle measurements. Because here we do not have any assumptions, we are directly measuring based on the electrical mobility technique. Okay, so this can measure from 1 nanometer up to 1 micron. Okay, but it is a scanning process. It takes 1 minute to 5 minutes based on the size range what we choose. Okay, and other very gold standard equipment for the bigger particles is aerodynamic particle sizer. Here, we are not assuming anything. We are not assuming density or particle size or particle shape factor. And we can directly measure based on time of flight principle with the help of aerodynamic particle sizer. Okay? So with these two equipment, you will be able to measure from 1 nanometer up to 20 micron, which is measurable range from of the real-time aerosol measurement. Okay. Now I will tell you a few examples what is going on around the globe, especially in the Europe and USA. There are new regulations came up to measure the aerosols from the ambient for the atmospheric studies or air quality studies, which is same standard, which is a European standard actually. They are giving a guidelines how to, for the researchers especially, how to measure the aerosols from the one ultrafine particles to the bigger particles. Which equipments you have to use? What are the things you have to keep in mind when you are measuring the aerosols? So this is one of the best methods provided by the ACTRIS network, which is Aerosol Cloud Trace Gas Network, which is one of the largest network in the Europe. Okay, so in this standard, they are giving you when you are measuring aerosols, you cannot put simply your sampling tube outside. You have to use certain things. For example, the sampling system and conditioning system. Because when you are measuring PM10 or PM2.5, the most vulnerable factors are relative humidity and temperature and wind direction. Wind direction anyway you cannot control, but temperature and relative humidity you can control with the help of some additional tools, small tools. Okay, so here they have given what are the requirements for the sampling and conditioning and counting and sizing. Everything is well defined. Okay. If you want to part of this network, you have to use the same things what they are suggesting. And this is the complete solution from sampling system to the particle sizing system. So you have to use RHT sensor, dilute its concentration is too high. And also you have to use a complete sampling system with a Neptune dryer. Then you will be able to get ultrafine particle size distribution from 10 nanometer up to 1 micron. So this is actually wide range scanning mobility particle sizer, which we launched last year, which became very popular in Europe and USA. And if you want to follow proper methods for the ultrafine particle monitoring or bigger particle monitoring, and if you want to contribute to the proper results, then I suggest you to go back to that link, ACTRIS network or set standard, read about that, and you can follow, you can learn a lot many things there. So now, I will. Yeah, so this is a complete solution as per the Bell network. Professor Dunkasar is also having this aerodynamic particle size for the larger particles. In addition to that, if you have this 10 standard, then you will be having complete solution for the from bigger particles to larger particles. So Now I'm giving it to my colleague, Sanjeev Kumar, who is taking care of environmental division. So TSI launched recently one of the hyperlocal sensors. He's going to brief you on that particular stuff.
Thank you, Rama. Hi, good morning all. So you can see these are the global data based on people face health hazards, and those hazards actually all related to particle only. So particle PM1 or zero point 0.8 micron particle. Nobody cares about. We do lot of research in terms of particle, but when it comes to your own health, nobody cares actually. If you see when you fall sick, uh, people say go to hill station where you will recover faster. And the only one reason for that is you will get more oxygen, less particles. But now hill area is also not safe. There also have lot of particles. So what happens when you talk about PM1 particle or zero point 0.8 micron particle that gets into your lungs, and from lungs it even gets mixed with your blood, and that damage lot of red and blood cells. So this mass concentration you already heard from Dr. Rama, smog you already heard. So if you come to So this is one of the most economical device where this will give you a liberty to do research based on your own requirement. So not only the device, with the device you can measure particle, and you can also there are different software which will yeah. So there are different software which will do calculation for you, like what SO2, NO2 does. And based on that, there are a couple of tools on our website where you can do the occupational health calculation. So suppose if you are exposed to 20 microgram of dust or fine particle in a day, and what in how many years may possible your lungs will damage. So think about when you are going back to your home, try to find out any vendor or any painter who do your car painting, or or mechanic, roadside mechanic. You find all are young only. You never find anyone which is who are plus to 40 or plus to 50. And the major reason is these particles. And these machines are really small. You can plot it at different location, maybe no at your society level, and where you can monitor. And there are a couple of solutions, which is water-based solution where you can clean your own area. So these comes with Wi-Fi connectivity, so you can connect with Wi-Fi, get the data wherever you need, and it also comes with inbuilt 16 GB card. So suppose sometimes there is no network, but data will be stored in your card, and you can take it and pull it out anytime. So these are some of the comparison with our own device, and Dustpack is one of the famous device where people are using sensors. They use this device to calibrate. So this is how when you plot this device and you want to give it to public and other people can see your data. So this is how look like on a map. So if you are doing a fence line monitoring of any industrial area, your college or university, you can actually see which area you are creating more of the particles, and based on that you can take some corrective actions. So yeah.
I just want to add a couple of things here quickly. So this Blue Sky was launched in 2020 actually. So we in other parts of the world. In terms India, we just launched last month. However, this Blue Sky has been used by research organizations like IIT Kanpur and other institutes. By the Duke University program, you can see a lot of sensors were installed already. The India sensors are not showing here because of some security reasons, but other parts of the world like Nepal, Bhutan, Bangladesh, they are all using the blue sky sensor, which is working very fine. We don't call it as a low cost sensor because there is no proper definition for the low cost, but we call it as a hyper local sensor because air quality changes from one location to other locations even if it is in 20 meters distance. So we are providing hyper local monitoring networks, both software and hardware, with which you can visualize the real-time data even from 1 second to 1 minute or whatever you can choose. time average, and it will provide PM1, PM2.5, PM10, and also gases. The latest version will come with the gases, and also the data analytics, which is powerful software. And here we are not doing any data manipulations. Okay, it is everything in your control, because you can see the provider service providers who are providing this kind of solutions, they are changing the calibration factors, they are changing some other parameters. We are not doing anything. It is everything will be in your hand. Uh, the cloud side will be in your hands. You download the data, you can see the data, you can visualize the data. I don't have much time here to give more details on this, but if you have any queries, please contact us. We will give you more information on that. So here I kept my uh, our email ID. Please contact. Okay. And one announcement, sir, with your permission. So TSI is into this aerosol research and instrumentation development since last 60 years with the help of University of Minnesota. We always encourage students for their future endeavors. So here also I'm announcing something which is maybe useful for you to encourage the students. I'm announcing 5,000 rupees of cash prize for the best oral presentation, and the organizers can decide who will be that. Okay? Thank you very much.
Thank you, Dr. Sachin Sanjeev. So, any questions?
Yeah, please. Both, sir, actually. It has both. In fact, it has VM1, PM2.5, PM10. Yeah. Yes.
So may I ask you one question? Why you need to monitor PM10? So, so PM10, no, if you get into the occupational safety industry.
Sir, basically all these sensors works based on the principle of single particle light scattering method. Okay, so based on the light scattering, so actually the instrument pull all the particles. It doesn't know whether it is PM1, PM2.5, or PM10. Okay, it measures all the particles light scattering. Okay, and it based on the light scattering intensity, it will plot whether it is PM2.5 or PM10 or PM1, or in fact our equipment can also give how many number of particles are in this each bin. And all these local sensors, they work, they don't measure directly the mass. They calculate mass from the total number. They assume that that's what I told. Direct method and the indirect method. This is the indirect method of mass measurement. Because everyone is looking for locus sensors. Okay. If you want to have a proper mass sensor, please go for the instruments like here. This is actually the bottom one, the first one, which is based on the. That's right. Yes. But I'm talking about this equipment, which can. No, no, that is different model, sir. You are measuring, you are using 8530. The model which is here, which is similar to that, that is 8533 model, with which you can measure four parameters at time: PM1, PM2.2, PM4, and PM10. Yes. Okay. Yes. So right now we are doing two projects. One with C-Step in Bangalore. We have given three sensors for the along with the BAM. They are doing one study. Probably I can share you the details tomorrow. Maybe if you want, I can share. I'll be happy to.
What is the average cost of this sensor that you have mentioned for PM10.5?
So without gases is close to 50 or 1,000 rupees, and with gases could be close to 1.5 lakh to 2 lakh rupees. Based on your gases combination.
Suppose we are consuming only particle size below than 2.5, suppose 0.5, 1,
Yeah, that is very much possible with the TSI software. So once you have the data, so then the integrated software comes with our device. So it will calculate point 0.5 as well. Yes, yes.
Is it possible to make the sample physically for the chemical analysis?
No, sir. Actually, for chemical analysis, we have offline equipment like Modi factors, which are called as a cascade factors. Yeah, I think that's similar high volume sampler. We have to go in the lab test with GC or that. Yes. Otherwise, you have to go for a high cost equipment like real-time mass spectrometers, which are there are three different type of real-time aerosol mass spectrometers, which gives every particle chemical composition. That is probably make a solution. Yeah, you can choose whatever you like based on your interest and based on your research.
Just you have mentioned the impact.
Yes.
So, in that impact, you segregate the different size from the different.
Exactly. Yeah. Exactly. And you. Yeah. So.
Sometimes I have report that there are different kinds of the impactors.
Yeah. That's why I'm not calling it as a cascade impactor. Our impactor technology is mono uniform, MODI impactors, which is mono uniform, uniformly distributed impactor actually. The particles will be collected through the very fine holes, so which is distributed uniformly on the each stage. Okay, so that is not Anderson impact. And if you look at our which defines Houston with a parameter called cut point. Cut point means one size particle should not interfere with other size. Okay, so we collect on every stage only that particular size range particles, and it will be uniformly deposited. You can do two things. One, you can measure the gravimetric mass of the particles of that particular size, and you can also do the chemical calculation with that particular size.
So is it the rotator is there?
Yeah, there are two models again. One is rotating model, which can collect uniformly deviation, even if you don't use the rotator, then still you will be able to get very uniform deviation. I think we can discuss later on. So yeah, you please contact us. I mentioned here our email IDs. So let's thank you, Dr. Amit and Sanjeev. So now we have some oral presentation. So I would like to request that Prashant Chauhan, Prithviraj, Rupal, and all other are that Aman, they should be ready for their presentation. Now I would like to request Dr. Alok to present the moment to Dr. Ramasetti and English. So now we are moving for oral presentation. So please, we have only 10 minutes. So keep 2 minutes for discussion, 8 minutes for presentation, and be in time. Huh? Online. So first oral presentation by that Mr. Prashant Chauhan. So he will be talking about the outflow of Asian biomass burning carbonate residue into the UTLS in spring radiative effect seen in a global model. So I would like to request
Prashant Chauhan. Prashant Chauhan. Yeah. You have 10 minutes.
Hello. So good morning, all. I'm Prashant Chauhan, working in IIT Pune. Today I'm here to present my presentation on how to ban. Hello. Today I'm here to present my presentation on the impact of biomass in carbon on the upper troposphere and the lower stratosphere. And we'll see how it is uh, interacting with climate change processes and how it will be working on like changing water vapor concentration and the heating rate and the forcing at the top of the atmosphere and the surface. So this is my title of the presentation. The flow-of-Asian biomass burning, carbon aerosol in the upper troposphere and lower stratosphere in spring and radiative in the water. So these are the outline of my presentation. Since biomass burning activity is most pulse over the Asian region, and since biomass burning activity is increased aerosol optical depth and direct impact on radiative forcing and the heating rate. Since heating rate is increasing, due to heating increases in heating rate, it increases the water vapor, and once water vapor increases in the upper troposphere and lower stratosphere, it may causes change the climate. So to understand the impact of biomass burning carbon aerosol, we did one experiment, and we addressed the question like transport pathway of Asian biomass burning carbon fuel source to the lower stratosphere during the spring season, and the impact of Asian biomass burning carbon fuel on the troposphere and UV. For this purpose, we employ the state-of-art ECAM6 thermochemistry climate model. This model is evaluated against the model satellite data, Aeronet measurement, and OSIRIS satellite-based instrument. We perform two sets of sensitivity simulation. First one is aerosol emission. Uh, uh, Aerosol emission from biomass burning where kept on, and second one aerosol emission from biomass burning where kept off over the Asian region. We analyze the difference between biomass aerosol on and biomass aerosol off simulation for the spring season 2013. And 2013 we chose because of 2013 was without impact of El Nino and the Indonesian natural solution. So to understand the impact of biomass burning carbon zero, so here we plot the higher spot plot for the Asian region. So we can see the fire spot clustered over the Indo-China region, Indo-China region and this China region and over the Indian region. This is the variation of peak during the spring season. We can see the Indo-China East region, South East and total Asia region. So peak is varying over the March, April, May, June season. So this is the AOD figure, aerosol optical depth. So this AOD is due to black carbon and organic carbon, and this is total AOD anomaly. We can see the more AOD due to the COC concentrated over the Indo-China region, and this is the total AOD. This enhanced AOD due to the dust aerosol, which is transported from this Pakistan region and this Gobi Desert. And we compared the model simulation with Osiris satellite observation to understand how the model is uh, working with satellites.
So this is the vertical distribution of simulated aerosol extinction profile. Average load 10 degree north to 30 degree north, and this is also a satellite aerosol extinction coefficient. Average load 10 to 30 degree north, and we can see the plume rising from 30 degrees to 120 degrees and extend up to 16 kilometers. And it is also evident in OSIRIS data. Although model is underestimate the aerosol extinction coefficient, the sign difference is consistent with the slightly shorter wavelength Osiris extinction measurement. This underestimation may be also due to the uncertainty in the model and the emission inventory transport process in the model. And since biomass burning activity enhance DOD, there is the impact of carbon aerosol on the radiative forcing. So, for the South Asia, Indochina, and East Asia region, the top of atmosphere radiative forcing is negative, and at the surface radiative forcing is also negative, but in atmosphere radiative forcing is positive. And here we show the transport process of biomass burning carbon aerosol into the upper troposphere and the lower stratosphere over the Indochina region and East Asian region. So we can see in this figure the transport process of biomass burning carbon aerosol is extended up to the lower stratosphere. This black line indicates the propofol, and this is average over. This figure is average over 91 degrees to 1107 degrees east. And this figure A to D for DC aerosol for the Indochina, and C to D for OC aerosol, and same for East Asia region. This transport process may occur due to the convection activity over this region, and the strong convective activity can transport this aerosol directly to the upper troposphere and the lower stratosphere. Here I have not mentioned the OLR anomaly that is the proxy of convection. And due to carbonaceous aerosol, emission over the Indochina region and East Asia region produced the anomalous peaking in the lower troposphere and near the propofol. The positive anomaly in peaking rates near the propofol is around 0.012 to 0.004 Kelvin per day in the upper troposphere. And also, transport of carbonaceous aerosol in the Western Pacific by Western region has increased emitting by 0.008 to 0.04 Kelvin per day. So here we can see this transport, the transport of this carbonaceous aerosol to the Western Pacific. Our heating may produce the biomass burning carbonaceous aerosol may affect the distribution of water vapor in the upper troposphere and lower stratosphere. We can see the transport of this water vapor to the upper troposphere and lower stratosphere, and further it is transported to the southern pole by the lower branch of the oxygen circulation over the Indochina region and East Asia region. This is water vapor anomaly at 150 HPA, and this is water vapor anomaly at 70 HPA. So this is the conclusion of my presentation. Biomass burning emission increase the aerosol burden AOD. This analysis shows over the Malay Peninsula and Indochina region, transport of carbonaceous aerosol from boundary layer to Indochina region, East Asian region to the stratosphere. The enhanced carbonaceous aerosol DCOC emitted from biomass burning produces significant negative net radiative forcing at the surface, at the top of atmosphere, and the positive in the radiative forcing. Change in biomass burning carbonaceous aerosol reduce warming, reduce warming in the troposphere and the UGLS, and the biomass burning carbonaceous aerosol lead to moistening of the troposphere of the northern hemisphere and northern stratosphere over the northern tropic and southern tropic. Thank you.
Thank you, Mr. Prashant. So, any questions? One or two quick questions. I think there is no question, so let's thank Mr. Prashant.
Thank you.
We will move next presentation. The next presentation by Mr. Prithviraj. So he'll be talking about the network measurement of aerosols and satellite data products over 3 locations in India.
10 minutes only.
Yeah.
8 minutes.
Good morning, my friends, respected sir and ma'am. I hope that goes everybody. I'm Prithviraj. I'm from IITM Pune, and this is my introductory slide of today's talk. Multi-axis differential optical absorption spectroscopy. I have taken this observation for three different locations over India, and I also compared our results with satellite. So after hearing this title, you might be wondering what is MaxDOS and how does it take observations and what are the three locations, right? So I will cover this all parts and I will conclude my talk as soon as possible. So I have the observations of MaxDOS over three locations: Pune, Delhi, and Mahabaleshwar. Pune is a moderately urban region in Maharashtra. It is the western side of India, and it is the leeward side of Western Ghats. Okay, it is a good city, good weather, and good people, of course. Uh, the next one is Delhi. We all know that where is the Delhi and the location, so I will just keep it because to save my time. And the Mahabaleshwar, it is a small town in Western Ghats. It's at a high altitude at around 1378 meters above the sea level. And fun fact about it, produces 80 to 90% of strawberries of India. Just saying what's so the background, I think our senior scientist has already explained that what is aerosol, how does it like difference in the other parameters, and how are they important, how they affect the radiation budget and the health and the environment. So I will just move ahead. But the most challenging task, what they say, that it is important to observe them. So what is the challenging and most essential part is to get the vertical profile and the information and the knowledge about the vertical distribution. So there are methods to observe the vertical distribution, like in situ observations, in the aircraft or balloon, and the ground-based LiDAR. But these methods have some limitations, like LiDAR only works at night. The aircraft and balloons, they are expensive and they are campaign-based. We don't get the long-term observations because of that. So we are here doing the max dot observations, which measures the continuous observations or any site. So this max dot, what it does, it measures the spectra at different elevation angles, and it will compare with the solar system angle, and it will give us the slant column densities of any trace gases. Like it measures the NO2, it measures the SO2, it measures the bromine monoxide and the iodine monoxide. But since I'm presenting the aerosols, it measures the aerosols. How does it make? Because so there is gas called oxygen dimmer. It's called an O4. It is the origin of oxygen molecules. So we can use it as a proxy for aerosols, right? So I did provide the reference here, but for now just trust it. So we have observations over Pune, as I said. So the spectral range, let's say there, it measures the different elevation angles at different in the spectra. So this O4 absorbs the solar radiation at two different wavelengths, like in the UV at 360 nanometers, and in the visible range, it observes the spectra at 470 nanometers. So it measures dark column density, and we analyze the spectra using the two dot software about the solar center angle 75. Sorry, below the solar center angle 75. Because after the horizon, the sun will set and we won't get the observation. So, but it will produce the dark column density. But for scientific purpose, we need the vertical column density. In aerosols, the vertical column density is nothing but the AOD, aerosol optical depth, because it's the integral of whole column. So how do we get that? Using the radiative transfer model. For my study, I am using the mind profile algorithm. It uses the Monte Carlo approach as a radiative transfer, and it will give us the vertical profile of aerosol extinction. Right? It will also give the trace acid, but I am relating to the aerosol. So how does it work? That we provide the plant current density, it will do the analysis and will give us the vertical column density and profile. But it doesn't care whether we are providing the right input or wrong input. So whatever the output we get, we have to filter it. For that, we have developed our own filters like cloud filter, high filter, RNS filter. These are the technical terms. If anybody interested, I would like to give them the talk after the speech. So these are the initial results we get from the MAPA,
Thanks for introduction. We have the AODs over Pune, Delhi, and Mahabaleshwar at two different governments with 46 470. The high value theory shows that local events at the near the site, like some fire events, or because of the patchy cloud, that MAPA is not able to differentiate between whether they are aerosols or the patchy cloud. For that, as I said, we have developed the cloud filters and all. So for Pune, we get AOD at PCC around 0.6. For Delhi, we get of the AOD around 1. For at 470, we get around 0.42. For Mahabaleshwar, PCC is around 0.9. And for 470, it's around 0.55. For Pune, we have the year-round observations from 2nd January 2018 to 8th July 2019. We can see in the monsoon season, most of the data is get filtered because of the cloud. Yet we see some small observations here, which are the result of the washout season. That's the well-known theory of it, that we already know. For Delhi, we have taken the observations in the monsoon season because most of the studies are not in the monsoon season. We want to know what happens in the monsoon season. So we have taken the observations in monsoon season. We see some observations, most of them are the clouds, but the state observations are more than the observations in Pune, every observation. For Mahabaleshwar, we have the observation, and most of the data is because of the topography. I will explain later how the observations are changing. Yeah, so after that, I have taken the monthly data variation. I will explain this even very briefly because it may take some time. So what's the key point we have observed here that for Pune and Delhi, we see some dial pattern for all the seasons. So you can, from the figures, at the first glance, you can see it is based on the convection or the boundary layer mechanism in the urban city. As the day progresses, the boundary AOD one increases, and as the day progresses, after the moon, the value decreases. Right? For Mahabaleshwar, it shows a different pattern here. Why? Because the boundary layer in the Mahabaleshwar in the morning is below the site. So as after the 12 p.m. or around 1 p.m., when the condition starts, the boundary layer will rise the height, right? So that's why we started observing the after every observation after the 12 p.m. Till now, the observation is steady. Yeah, so this is the main part of my talk today. That we get the yeah, I'm just this is the main figure that we get the vertical distribution of the aerosol. In Pune and Delhi, most of the aerosol concentration is below the one. For Pune, it's below the 500 meter, and for Delhi, it's around 1 kilometer. For Mahabaleshwar, we get higher concentration up to around 3 kilometers because of the topography. At surface, it is low concentration, but as we go high, the concentration increases up to 1 kilometer and again decreases. That means it says that there is an elevated layer of aerosol. Then we have compared our observations with the Modi satellite, Modi Terra. We match the time. But because of the cloud filter and the cloud fraction by satellite, most of the data get moved. That's what is necessary to take observations, long-term observations over the east. Yeah. So today and Delhi and Mahabaleshwar at 360 nanometers, however, we get a decent correlation with satellite. But for 470, the correlation is not as good as for 360. But yeah, it's because of the small data set, we cannot judge exactly how the correlation is. For Mahabaleshwar, compared to urban locations, rural area has a good correlation. This is the frequency distribution of delta AOD. Delta AOD is the difference between MODIs and the max loss. We can see if you understand if you know how the normal distribution works, you can say that for 360 MODIs is slightly underestimating the max loss observation, and at 470 is slightly overestimating.
You can conclude.
Yeah, next is conclusion. Yeah, so in conclusion, AOD is strongly based on the modular mechanism, and the major action of the loading in the bottom layer and triangle and distributor. For Mahabaleshwar, the layer has been extended up to 4 kilometers. Modi is slightly underestimating at 360 and overestimating at 470. And we found the two correlation over the three locations at EV. Yeah, these are the observations.
Thank you. Thank you for nice talk. So, first of all, I will ask you one question.
Yeah, sure.
From which instrument you are taking that AOD?
Max loss observation. maxwell, multi-axis differential optical maxwell.
Whatever the AOD you present is a better background.
Yeah, it is a spectrum, right?
Your AOD value is very high.
Yeah, very high.
You check the data quality,
Yeah,
because
that's
even in Mahabaleshwar you are getting up to 4.
Yeah,
That is not.
that's what I said, that we have using the cloud filters. So it will make, remove
I
the
think,
all cloud.
I think it's not cloud screen data. You are presenting whatever the coming with the command you are presenting.
For example,
Even in Delhi also you are getting very high value.
yeah, for
That's not
example,
true. Anyway, any other questions? One quick question. If there is no question, let's thank Viraj. The next talk is by Rupal. So she is talking about the satellite stable burning activity in northwestern India during 2021. So Rupal, be in time. We have only 10 minutes.
Okay. Hello. A very good morning to all of you. This is Rupal Ambulkar from IITM Pune, and today I will be delivering a lecture on stubble burning in northwestern India in 2021 and what is its contribution to air pollution in Delhi. So this is a very viral topic nowadays. So let's proceed with my slides. Okay. Okay, so whenever we hear the word stubble burning, the first thing that comes in our mind is parali burning or agricultural fires. So, what is meant by stubble burning? It is intentional incineration of the stubbles, which is done by farmers after the harvesting is done. So, stubbles are usually the cut stalks or the piles of the grains which are left in the field after being harvested. So, it is a year-long problem, and I mean, it is practiced all over the globe, but here we are focusing more on the northwestern part of stubble burning because we wanted to see how it is affecting the air quality over northern India. So, farmers usually prefer this kind of stubble burning practice because they find it less time consuming, inexpensive, and rapid means to sow the next round of crops. Okay, then what is the motivation behind this study? See, we have a lot of population growing all over the world, and with that, there is a production increase in the production for food grains and food. So basically, for Punjab and Haryana, we are mostly dealing with rice production. So if the production of rice has increased, that means the possibility for the more generation of waste has also increased, especially in those states. And therefore, we have also seen in the last year that 21 million tons of cereal crop residue has been burnt in the last year, during the whole year. And then, particularly at the time of winters, we have seen that 7 to 8 million tons of residue has been burnt, which is quite a huge number. So average PM2.5 concentrations in Delhi also we have seen that it was counted by 120 microgram per meter cube last year, where in several episodic events we could also see that it has shoot up to 900 microgram per meter cube, particularly at the time of Diwali events. And then still now in the whatever the effect of stubble burning is there on how much it is affecting over Delhi, it is still sparse, and that study needs to be more quantified, and therefore we are trying to figure out several methods, and still the government and our agencies are working on that. So I would like to start with this figure over here. So this is a spatial distribution of Morris active fire count data. So clearly we could see here that Punjab and Haryana, they dominate the fire counts. However, the remaining states of UP, Rajasthan, Uttarakhand, Himachal Pradesh and all, they have lesser fire count densities. Over there, that is a daily active fire count in Punjab and Haryana. So we could see that, okay, so we could see that there is a very episodic behavior the sudden increase in the fire burning events, and then which is encapsulated by decrease in the fire burning events. So this unique fire pattern is there. Also, we have seen that there is a peak of the burning season which is observed during the first week of November. And then, so this is a cumulative plot as we have made for 2000 from 2016 to 2021 over here. So this is the accumulation of modest fire count events, and we could see that the fire events they gradually increases in the first half of the burning season. But in the second half of the burning season, the fire counts rose rapidly. When we talk about the year 2021, so here we have seen that there is a very subdued behavior of the fire counts. I mean, the fire events are under control. But then, as soon as we saw the in the second half of the burning season, this the last curve, the maroon burn, which is for 2021, it has rose rapidly in such a way, so it has surpassed the cumulative fire counts for the last 5 years, and therefore we could figure out that the fire burning events they were highest in the year 2021 as compared to the year 2016. And also, we have seen that when we compare the burning events from 2021 to 16, we could see that there is a very delay in the burning period as compared to 16 by 1 week. This modeling system, which I am going to talk about later, it also suggests that we have the contribution of biomass burning about 30 to 35% to the air pollution load in our country. Okay, so this is another thing which has been developed by our group. So this is an air forecasting system named as Air Quality Early Warning System in Delhi, which is one of the, I mean, first of its kind air forecasting systems in the whole world, and it gives an accurate city-centric forecast, and it is extensively operationally by the air quality enforcement agencies, which tries to maintain air quality over a particular region. And the Commission for Air Quality Management has been also extensively using the updates which have been given by AAC-2022 and DSS, that is Decision Support System. And a new policy has also been made by AAC-2022, which states that whatever the efforts to control the pollution in Delhi, the government is trying, the CPCP, CPCC, and CQMS are trying, they will try to work on the predictions which have been made by AAC-2022 and AAC-2022, sorry. And so, see, this is the research, and we are trying to reach to the policymakers and then to the scientific community, of course, as a whole, so that we can complete a loop. And then, if you have any other further queries, I would request any of you to contact these reputed speakers, and then I think that they will help you resolve your doubts. Okay, so here, using that AQAWS, we are trying to study the impact of fires on the air quality of Delhi. So first of all, we have used an approach of chemical data assimilation with the help of Wattke model and Edgar emissions and fine resolution daily inventory, which we have prepared at 400-meter resolution. We have incorporated those into the model. Then we have Mozart Bocard chemistry mechanism, which we have also incorporated. The initial and boundary conditions for methodology is given by IATM IMD GFS model. And then we have also made into account MODIS and VRS fire products. And we have prepared emissions assimilated with their fire activities. We have also assimilated MODIS AOD and surface PM 2.2 observations so that we can improve the initial conditions of the model. And then we have tried to see the impact of chemical data assimilation over our results and how it has improved the air quality forecast. So, okay, so these are 43 AQMS patients from Delhi. So we could see that after assimilation, this main slide, after assimilating fire into the system, we could see that our open model observations were in close match with observations obtained from CPCP, which is denoted over here in black in color. And also we could see that there is a very nice representation of PM 2.5 values, which has been obtained from biomass burning over Punjab and which has been captured nicely by the model. Then also over here, we have tried to, in our study, we have tried also to see the contribution of carbon monoxide and PM 2.5 from such biomass burning activities. and how it has affected the pollution load in Delhi. So this is the contribution of carbon monoxide from fires. As you have seen in the previous figure, that as the burning period progresses, we have seen that the carbon monoxide concentration also increases. When we see the contribution of carbon monoxide from fires to the total CO emissions in Delhi, we could also make it from the model. It has been analyzed from the model that there has been a 30% contribution of carbon monoxide to the air pollution load. Now, this is a slide where we have tried to say the contribution of fires to PM 2.5. So similarly over here, it follows the same trend as compared to that for CO emissions which we have seen in the previous slide. And over here, yes, one minute. So here we have tried to see since they follow the same pattern. So there has been a contribution of about 35 to 40%. We can say from the model which has been estimated from AQEWSS that this is the contribution of fires to PM 2.5. Now, these are some of the conclusions from my research article. So, here we have seen that the stubble burning in the last year, it was highest as compared to overall 5 years, and we have made the cumulative plot also, I've explained that before. And we have seen that the fire counts, the rise in the fire counts were initially very low, but they have increased to about 20,000 at the end of the fire season, which was very high. But obviously, in this year, we are still trying to figure out a way, and we will be working on that and tracking the way how the biomass burning is affecting Delhi now. And there has been a temporal shift, which we have also seen on the plot. And the contribution is around 30 to 35%. And we are trying to reach the policymakers so that better mitigation approaches and strategies will be followed and adopted. Thank you so much for the patience.
Thank you, Rupal, for very good talk. So, any questions? Yes.
Yeah,
Yes.
continue.
I'm only wondering that why are we not concentrating in the summer season?
Right.
Because during the Rabi season is also very important, and in India we have not taken so much into account, and we are only talking about the current year.
Okay. Thank you so much for the question. I just wanted to say you that my study is basically dealing with burning period, and that is basically after the monsoon. And here we also have seen that stubble is mainly associated with growing of the rice over here in the northwestern part of India because the production of rice is very high in those states, that is in Punjab and Haryana. That's why we are studying on that. And plus, one more point is there that stubble burning is playing a role in affecting the quality of Delhi. So, I mean, I will be dealing with that as well. The Rabi season crops and all burning, I don't have much information on that, and that's why I will be studying the stubble burning in order. Yeah, I have read it. Yes. Yeah, I think I might have read that.
2021 paper. 2021 paper.
In fact, in the Beyond Journal itself, this paper is also there. You will see that in further days. Okay, you will
Yeah.
see that.
Yes.
Um, I don't know. I mean, see, these 5 information we are taking from models which has a resolution of 1 kilometer. Yes.
No, 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 no. The fire count is the total fire count. It is not only stable burning. Body is not separating. This is stable burning. This is wood burning and the other burning. So it is total. Yeah.
Okay. So I think think that is ultimately the preparation of emission inventory, which I'm still working on that because that is the thesis of my project now. And if I get a chance in 2 3 years, I will present that thing also, how to do that.
We cannot distinguish that. So, any other question? Yeah.
Yes. See, the model framework and all, I'm still not very well versed with that. And if you want, we can discuss this later in detail much. Because right now I cannot explain that to you. So I will look into that and let you know.
Simple one question. So, at what confidence level you use the fire count?
Yes, sir.
Which confidence level?
So according to SIN, we 1.5 there was 20%
No, that,
confidence level.
no.
So
If you are seeing the body fire, there are confidence level in there.
yes,
Or
yes,
if you in a you can say the brightest temperature.
yes.
So at what confidence level you are 80%, 20%, 90%, 30%, what is it?
So in our
Because if you are using all the data, then there are a lot of uncertainty and
uncertainties are there, yes.
so check that.
So till now, it's 20% is the highest confidence level which we have taken yet. And yes,
Yeah.
yeah, but
Yeah, we can say above 80%, then we can say then this is a fire. Otherwise, we cannot say this is fire.
that is the highest.
Yeah. So that's why your data.
See,
Anyway,
I have just run this model. Okay, so the data has been provided by several people in our group. So that is the thing.
and the WRM, which grade resolution you are using?
10 kilometers for the outer domain, and then
10
400 meters
kilometers.
for Delhi.
But now it is you have high resolution also available in WRM.
Yeah, but sir, for Delhi domain, that is, we have done dynamical downscaling, no? So for Delhi domain, we have used 400 meters resolution.
Okay. Thank you.
Okay, thank you so much.
So we have next presentation by Mr. Aman Sriwas. So he is talking about the study of black carbon aerosols in the Himalayan foothills Dehradun during the COVID-19 lockdown period. Mr. Aman.
Hello, good afternoon everyone. My name is Aman Shrivas and I'm working in Wadia Institute of Himalayan Geology under Dr. Chavipant Pandey. And my topic for today's presentation is morphological characterizations of black carbon aerosol particles in Himalayan foothills Dehradun, and that is true during lockdown of first lockdown. So, just for the introduction part, we all know that atmospheric aerosols are small particles of solid and liquid that are suspended in the air. As you can see in the diagram. Okay. Okay. So, so for the methodology part, our institute is situated in the Himalayan foothills, that is in Dehradun, and we have used the instrument ATLO micro AE51, and this instrument observes the optical parameters, and it gives us a filter tape that is used for the morphological part. And the tools that we have used for sample analysis are SAM88 and for computational analysis and remote sensing also is used. So the morphological parameters such as aspect ratio and circulatory factor of ambient aerosol particles have been studied in this particular presentation, and the morphological parameters of aerosols are derived from these two formulas: aspect ratio, that is derived with maximum projection and upon weight, and for circulatory factor it is 4 pi into area 1 perimeter square. And yeah, so the frequency distribution of AR and CIR of black carbon particles from the sampling site, it can be determined by its sphericity. So the ideal condition of a black carbon particle is a sphere when AR and CI are both equivalent to 1. Now, for analysis, I have used the same images of the filter paper, and I have analyzed it using ImageJ, and we have studied the AR and CIF of the particular area. So, to determine the AR and CIR values of the particles, a total of 392 particles were studied using ImageJ, and the chart has shown the distribution of the sizes. So this is the frequency distribution graph. For AR, it is highest between 1.1 and 1.2, which is normally ideal, which is near to the ideal situation. And for CIR, it is around 0.95 and 0.9 to 95. That is also an ideal situation. So it was because of the lockdown situation, because there was no biomass burning or any kind of disturbance of from fossil fuels. So the correlation that we did was between remote sensing data. So a dedicated study with the help of MIRA data that we use for aerosol optical depth for the year 2020. The study area shows that the AOD of the particular area was between 0.16 to 0.24, and the wind trajectories were used from the model data, and it shows that most of the particles were regional transported particles, and we have also concluded that it might be possible that the wind that are transported are from the regional forest fires and Indian summer monsoon, and maybe to some extent western disturbance. So, for conclusion and way forward, we can say that the morphological characteristics of BC particles, such as AR, is highest between 1.1 to 1.2, and CIR is at its peak at 0.9 to 95. And these BC particles are relatively spherical in shape, and but this is an ideal condition. So the sphericity of a particle suggests that partial effect of anthropogenic activities, and that is the partial effect of anthropogenic activities, and more of the geogenic activities were present. So that is only because of the COVID-19 lockdown in the first time, and satellite data were used that I've shown, and we are trying to expand our area. And yeah, thank you.
Thank you.
If any question, please.
So questions? So just I want to ask one thing.
Yes.
So your title is related to the COVID-19 lockdown black out. You don't have any temporal value for that?
Sir, temporal. We have used
Which period you use on COVID lockdown? How many periods you use? Time period.
time period was between May to June.
So how you can say this is if you put the black carbon temporal value, then you can say oh, it is.
So sir, we have only quantified the morphological parameters using image.
Okay, we are using MIRA data.
Yes, sir.
MIRA IoT, right?
Yes, sir.
So any ground validation about that? Did you validate the MIRA data? MIRA is real analysis data. It is not measured data. It is simulated data.
Yes, sir.
So did you validate that?
No.
So before using the data,
I
you validate it.
I have used the RG data, 8R data, and then only I have.
Anyway, check it. Because before using, you should validate the data for any site. Then you can use it for your project. Okay, that paper from the Anyway, thank you. So next talk is by Prachi Goyal. So she is talking about the air quality management in hilly regions, critical analysis of northeast Indian states.
Hi, good afternoon, everyone. Today I'll be giving a talk on air quality management in hilly regions, critical analysis of northeastern Indian states data. So in my today's talk, I'll be talking about some prerequisites that needs to be focused on before prioritizing any air quality management strategy. And with my talk, I request you all to not only think what government can do, but we as individuals how can act as the agents of change. So, if I begin. So as we know that nowadays most of the focus is on like Delhi, NCR, and the ITP region, and we have seen that since the air quality is generally determined by three factors like sources, meteorology, and geography. So it becomes important to understand that as the air quality considerably varies from hilly regions to plain regions, we need to shift our focus as well. We need to broaden our vision in the sense that we need to also cover these hilly region areas in our studies in order to know that these cities also require air quality action measures in order to tackle the air quality problems. Say, these increasing air pollution levels and associated health risks are an important are causing a great problem. And in view of that, the NCAP 131 cities are identified under NCAP, and that also covers not only the regions located at plains but hilly areas as well. And though the government is providing us with financial, technical, and logistic support, so we need to align and think in that direction as well. So if you can see, this is the map of India showing the NCR cities identified. And there are the two pictures. The one is the road dust that is taken outside the status. And another one is open burning. This is the picture taken from this girls' hostel in the Chauras campus itself. So we need to work, I mean, from here itself and later on think what government can do. And with this vision, I'll be focusing about the air quality levels and the measurement measures that can be adopted thereafter. Next slide. So talking about the objective of the present study is an attempt to analyze the data in hill regions and plain regions. And for that, I've taken the station from 8 continent stations located in 7 states, 2 hilly and 5 plain cities have been considered. And talking about the stations, 2 are from hill region and 6 from plain. So talking about the considered parameters, I'll be talking about PM2.5 and S2. I'll be restricting my study on this depending on the data validity. So I'll be talking about the interstation comparisons, then seasonal, monthly, annual variations, then compliance with the regulatory norms, and the correlation. And further, I'll be converting my study into mitigation measures that can be adopted in different states. So talking about my criteria for the hilly locations and plain regions, the hilly will be something wherein the altitude is more than 1,000 meters, and plain is something wherein the altitude is up to 400 meters. So these are talking about these study locations. Then here are these locations and talking about the details. So 8 locations have been identified. Like these are just selected at random. You can take it. So talking about the locations as per the classification criteria. So the city region has been stations that have been considered are Kohima and Hyderabad. And further, for the main region, we have considered 6 stations that is in Naharlagun, Siliguri, Araria, Kishanganj, Guwahati, and Agartala. What is to be noticed here is that the land use of all the locations is different. So accordingly, the sources and the related emission categories contributing to the emission pool will vary. So I'd like to uh, request you all to have a vision at the land use site, green area, remote. Then here definitely we'll be having the natural pollutants. And if I talk about the other locations situated at the same region, then some are commercial, some are institutional, some commercial, and some are institutional. So on it goes, and definitely accordingly the quality will vary. So moving on to the time series plots of PM2.5 and related descriptive statistics. And here are the two graphs, time series plots showing the variations in the PM2.5 levels. So you can see from the graph that upper one is for hilly region and lower one is for plain region, and it's clearly visible that the concentrations are more at plain region in comparison to hilly region areas. And if I talk about the plants, the standards, then mostly the concentrations are correlated in both monsoon, winter, and few summer months. So not only the problem is critical, not only the plain region, but at hill region as well. So the magnitude definitely varies.
So here's the descriptive statistics. Here you can see that Kishanganj in Bihar is the most polluted, and Aiza and Kohima you can see the levels are considerably less. So moving on to SO2. So here are the time series plots of SO2, and from the graph, you might be wondering how can there be this consistent pattern. Actually, this is the data quality problem. If you will retrieve the data from the portal, then you will find such issues, which indicates that there is a need for proper maintenance and calibration of the instruments located at the CHMS deployed at different areas, because ultimately this is affecting the quality of the data, and naturally some people might be publishing this in the public domain as well. So data quality, data assurance is something that needs to be worked on, because ultimately these are the levels that are considered for prioritizing any strategy. So herein we are focusing on only PM2.5 due to the data quality issues. So here is the calendar plot showing the annual variations in PM2.5 concentrations, and I've taken one recent derivation from the and plain region. So you can see from the color code as given in the legend that the air quality issues here refers to the exceedance to the standard of daily variation of 60 micrograms per million cube. So the problem exists both in the and plain region, and further due to the influx of the tourists and increasing footfall, the problem might become grave in the upcoming days. So talking about the variations with respect to the altitude, then here is the bubble plot showing annual average PM2.5 concentrations of different selected stations at different altitudes, and the bubble size represents the altitude level, and the y-axis represents the PM2.5 concentration. And from the graph, it is clearly visible and clearly evident that with the increase in altitude, the PM2.5 concentration decreases, because there are high wind speeds and microscopic irregularities in the surface, definitely with the turbulence is more and the dispersion and transport is more. So moving on to the monthly variations, then again the uh, trends are more or less similar, like concentrations are more at plain region with respect to hilly region, and within, though the trend is same, however there are certain variations which needs to be accounted, because ultimately every location has its own unique activities in the vicinity, in the close proximity, so which needs to be investigated in detail, and microanalysis needs to be done, because then only we could account these variations and plan for the further strategy. So talking about the seasonal variations, then if I talk about plain region, then the concentrations are definitely more during post-monsoon and winter. However, if I talk about hilly regions, then the problem is more during summer season as well. So we need to work accordingly and think accordingly, because the strategies for one season cannot be applicable to others. Because considering the heating practices, so there is a variation in the magnitude, so accordingly the control actions also need to be judicious. So talking about the correlation analysis, then here is the correlation table between the individual stations, and then we are taking the annual trend. So if we talk about the correlation, then the stations at the hills are correlating well. Then again, the geography and seasonal systems would be the reason. And if I talk about the regions at play, if I talk about two stations located in Bihar, like you can see that they are correlating well. So the sources might be common, but not with any other station, because they again that will be depending on the activities in the immediate vicinity. So further supporting this with some evidence, it is the back trajectory analysis of summer season, wherein you can see that if you will see here, you can see the origin of the masses from where the air parcel is originating, and this is taken from the -180 data. And if I talk about the inferences from these four back trajectories of these representative stations, then the upper air trajectory of Kishanganj, Siliguri, and Kohima have similar patterns. There's no correlation between Kishanganj and Siliguri, which might be due to the different back trajectory patterns and accordingly sources of origin. And Agartala and Kohima have similar plots, and due to the similar trajectory profiles, and similar was inferred in our correlation table as well. So similar inferences were drawn for other seasons. So without taking much time, talking about the measures that needs to be adopted. So if I talk about vehicles and traffic management, and as you must have already seen the traffic scenario outside, then redirection of the traffic movement provides suggestions, especially at traffic intersections and ticket areas. Then there should be a regular checking of vehicle emission and issue of engine under control certificates due to the continuous accelerations and the decelerations. Then minimize the use of diesel vehicles. Talking about the construction part, then transportation of material in cover systems, and restriction of storage of material on the roads. Then if I talk about the biomass and garbage burning or the use of solid fuels, this is quite common in many regions, and there should be restrictions on open burning. Then there should be ensuring the promotion and use of cleaner capacity cleaner fuels, then restriction of wood and other practices. And if I talk about the public outreach, then there should be mass awareness programs, increasing penalties, which will definitely increase the deterrence among the public. Then fiscal incentives for going green would be one of the major initiatives that could attract people for going green. Then talking about the strengthening of air quality monitoring network, then there is a need for installation of air quality monitors at clustered and traffic or congested areas in order to identify the priority locations which can be called as hotspots, because ultimately we could have some priority locations that needs to be acted on, and accordingly these measures can be released. Any questions?
Thank you, Bharati. Any questions? Yes.
So, when you talk about 7C unit station, so have you validated that data you check with manufacturing before, or have you tried to take,
Actually, this is the data of continuous station. So it is retrieved from PCR portal where there is no such detail of the track meter. That is there is the direct data, and I've retrieved that. So that's why there is a concern regarding the data which itself automatically shows that there is a need to check that particular instrument because their data inconsistent.
so the state who are covered, if you go to CA unit station,
Yeah.
they are not at the area where it need to be monitored.
Yeah, I understand. It might be reached not.
From the road, if you talk about Bihar, Mizoram, Orissa, so they are far away from roads. They are covered with trees. So
Yeah.
you never get the accurate data. And that's the question of the resource.
Yeah, actually, location of the monitoring station is also a big issue because in Delhi also there are many stations that are located under the tree, which is actually not representing the ambient air. Yeah, that aspect also needs to be looked at. I agree.
Any other question? So if there is no question, let us say thanks. So next talk is by Anita. So she is talking about the spatio-temporal impact assessment of land use and cover changes on urban heat island and air quality data Jaipur.
Namaskar everyone. The topic of my research is spatio-temporal impact assessment of land use land cover changes on the urban heat island and air quality over Jaipur district in India. Firstly, as you all know, the land use and land cover terms are often used interchangeably, but there is a slight difference between the both. That is, the land cover means the physical or the natural cover, and the land use term. Sorry. The land use term refers to how the humans use the land for their socio-economic, cultural, and political purposes. And as any area undergoes the urbanization process, there will be definitely a change in land use land cover pattern. That majorly you will find that there will be an increase in built-up area and decrease in the vegetation, wetland, water bodies, forest cover, and agricultural land, which will lead to high rate of evapotranspiration, increase in greenhouse gases, air pollution, disturbances in ecosystem processes, changes in carbon stock and sequestration, and loss of biodiversity. Along with this, when built-up area increases, this will further lead to increasing trend of temperature, high variability of rainfall and weather patterns, low infiltration rate, and rapid fall in groundwater and low plant productivity, which in turn highlights that there is a need for urban planning for sustainable cities. So the objective of my study was to map and analyze the land use land cover changes for the year 2009 to 2019 in the Jaipur city, to study the correlation between the changes that happened in the land use land cover and the urban heat, to study the impact of land use land cover changes on the air quality, to study the impact of land surface temperature on air quality, and to study the association between
concentration of air pollutants and planetary boundary layer using the no high split reducing model. So the study will help in the outcome will help in predicting the changes in future urban development plans, will help in devising the strategies for future sustainable urban development, will help in evaluating the impact of land use, land cover on environmental components in studies related to urban heat island effects as a basis for dynamics of pollutants within the planetary boundary layer, as a basis for source apportionment studies of air pollution, and will act as a database for assessing the harmful impacts of air pollution on communities. So the methodology, the study area is the Jaipur district, which is situated in the Rajasthan state. This is a methodology which in detail I will be explaining. The satellite datasets that I have used is Landsat 7 and Landsat 8 datasets. And in this, majorly the bands which were used was blue, green, red, NIR, and thermal infrared bands. So the images were first pre-processed and flipped. Then the Landsat 7 and 8 datasets were undergone the supervised classification method, and after that the mapping was done using this algorithm, which is maximum likelihood algorithm, and then the maps were classified into three categories basically: the built-up area, vegetation, and other. The water body was not considered here because in Jaipur region there is no such major water bodies that are situated. So we have avoided or we have taken that water body in the other category. And then after mapping the LULC, the change detection was being analyzed. So these were the results. Majorly, the Jaipur district has experienced the urbanization in the city area. Majorly, from the table you can see that there was a maximum increase in the built-up area, that is 26.55%, and in respect to 2009. And there was a slight increase in the vegetation also, but in comparison to the built-up area, it was very, very negligible. Then for assessing the urban heat island, we first analyze the land surface temperature of the area, and for that Landsat 8 and Landsat 7 datasets, thermal band datasets were being retrieved, and then the digital values were being converted to spectral radiance, followed by the conversion to brightness temperature, and then the Kelvin temperature was being converted to Celsius. And similarly, simultaneously, the NDVI was calculated, and from that emissivity was calculated, followed by the estimation of temperature. The LST maps that we got, then we reclassified that maps into different temperature categories, followed by overlapping it with the urban land use map vector file. And in this way, we identified the maximum temperature range values or the urban heat islands. And for the temperature category that we have used is the heat wave criteria category that has been given by the Environmental Department. The reason behind classifying the urban heat island based on the heat wave categories is because, firstly, this is a very dreadful for human health, and secondly, no research up till now, till my knowledge, has assessed these urban heat islands with this point of view. So the results was very dreadful. The mean temperature was found. There was a difference of 5 degrees Celsius between the two in the decade from 2009 to 2019. And the urban heat islands were categorized into two categories. One was the normal urban heat island. In 2009, no severe urban heat islands were found, but in 90s, there were so many urban heat islands and the severe urban heat island areas were there. And majorly they were in the city region. For assessing the impact of LULC on AOD, the categorized land use land cover was categorized, and the AOD data was being retrieved at 440 nanometers from Aeronet network, and from that the monthly averages were being computed and then followed by the impact analysis. In 2009, similarly, the AOD values were found to be less And in 2019, there was an increment in the AOD values with the increase in urbanization. This clearly impacts that there is an impact of increasing urbanization on the AOD values. Then followed by the assessing the impact of LST on AOD, the AOD values for 440 nanometer was retrieved and then LST maps were taken, followed by the impact analysis, which also showed that there is a, due to increase in the urbanization, there is a very high increase in the temperature ranges. For assessing the association between planetary boundary layer and AOD, the planetary boundary layer data at 500-meter height was taken from NOAA high-split back trajectory model, and from that 24-hour trajectory models, daily averages were being computed, and similarly the AOD data was retrieved, followed by the estimation using Carl Pearson correlation method. The results were not so influential. The planetary boundary layer was not so influential in the year 2009, but there was an influence and decrease in the p-bill, which shows that with the decreasing p-bill, there is an increase in the AOD value. And there is no such standards for AOD values, but the Earth System Research Laboratory of NOAA has given a standard, and according to that, if there is a value of 0.4 value of AOD, then it is a very hazy condition, which is not good for health. So in our research, we found the values were till 0.65 in the year 2019. So it clearly indicates that with the increasing urbanization, there is an increase in AOD and there is a decrease in people, which is again a very alarming stage. So with this, we can the study concludes that the urbanization has increased over the years, majorly in the southeast, west, and the northwest part of the region. The vegetation was found to be increased, but it has a very negligible impact on the urban heat island or in the pollution load. The land surface temperature was found to be increased by 5 degrees during the decade. Urban heat islands was found to be increased and intensified during the decade, and the AOD values was shown a substantial increase during the decade, followed by the reduction in PBL height. So we can conclude that the district has, in the decade, has undergone a rapid urbanization and industrialization, and there is a dire need for continuous monitoring of land use, land cover, along with the development of rational, scientific, and sustainable urban land use plans. It also highlights that the key urban area for highlights the key urban areas for work. That is the urban heat island spots that we have identified, which needs a dire need or a major planning, and it represents the potential use of study to understand the driving forces, the key hotspots, and in devising the sustainable land use plans and policies for maintaining the balance in ecosystem. And there is a need for careful and regular examination of feasible heights in order to track the sources and transportation paths of this. Thank you.
Thank you. Any questions? Yes.
Uh, so in satellite, we get the entire spatial data. So there is no data point, the continuous point data are there. From that digital numbers, the pixel values, we calculate the LST values. There is a lens, there is a satellite handbook from which they have prescribed the format from which we can extract the temperatures. Yeah. Yeah, yeah. So it depends. So I have taken one image from 2009, summer image that is from May, and similarly May image from 2019. And okay, thank you.
Thank you. Yes.
You have used average level 1 day. It is not quality.
Yes, sir. But the limitation with me was that the AOD data level 2 or level 2.5 was not available for the Jaipur region for this time period. So due to that, there was a foundation that I have to use the level 1 data. Yes, sir. Yeah. So we will now. I think we will be able to get the level 2 or level 2.5 data, because when we were doing that work at that time, level 2 data was not available.
Thank you. No question. So we can move next presentation. So next presentation is by Janam Mustak. He is talking about the comparative analysis of particulate matter and trace gases in between satellite data and the ground-based measurement.
A very good afternoon, everyone. Myself, Zainab. I'm a research scholar from Chauras University. First of all, I will be very thankful for the management team for organizing this platform as we will be able to discuss and exchange the different ideologies of our research. As you all can see on the slide, my topic for the presentation is comparative analysis of particulate matter and trace gases in between the satellite derived data and the ground based measurements. When we talk about the air pollution, it's actually the matter of concern. So, in a broader term, we can define it any physical, chemical, or the biological agent that's altering the general characteristics or the natural characteristics of our atmosphere, and those alterations are usually carried out by the different types of the pollutants, usually called as aerosols. Now, what are the aerosols? There are the different types of the aerosols. Aerosols are actually the solids or the liquid particles. They are usually dispersed in an atmosphere or in a gaseous suspension. And here the gaseous suspension is actually atmosphere. Coming to the types, there are the on the base of their formation. On the base of the formation, there are the two types of the aerosols, that's the primary and secondary, and as well as on the base of their source, they are natural and anthropogenic. While we are talking about the pollution, so we also have to include the different phenomena. Like here we are talking about the particulate matter or PM. Now, what is the PM? It's actually the tiny, very small, tremendous, tiny particles and the water droplets. There are the different types, as many of the scientists and many of the scholars have already mentioned the types of the particulate matter. There are the coarse, fine, and ultrafine particles. In case of the coarse, we have the PM10. In case of fine, we have PM2.5, and in case of ultrafine, we have 0.1. All of these are having, they can reach, they are all actually inhalable particles. But the difference is, like up to what extent they can harm the human and up to what extent they can reach to our respiratory organs. While we are talking about the PM10, it can just deposit in the extrathorax or the upper tracheal bronchial region of our respiratory system or the respiratory tract. And coming to the fine, it can deposit deeper into our lungs. And for the ultrafine, that's 1.0, it can pass into the circulatory system as well. That means it's more harmful among the all. So, according to the report of WHO 2016, around 4.6 million premature deaths has been there globally due to the air pollution. As we already know that there are the different sources, and as I already discussed, okay, there are the different sources, like we all know, like they are coming from the burning of the biomass. There are certain like the natural sources, like the volcanic. There are certain industries. These are just the sources of the aerosols. Coming to the suspended particulate matter, we have dust, fumes, smoke, mist. As all of you can like see, the dust is of just the fine particles of the solid matter, fine particles of the fine airborne particles, that is the fumes. Smoke, that is the visible suspension of the carbon and the other particles. And the same is the mist, that is the small droplets of the water. Here in this slide, we can see our area of study.
The sampling campaign has been carried out in the Delhi NCR region. As you can all see in the figure, we have chosen the 4 different locations. The first one was Darkwa, Delhi. Second one was Vivek Vihar, Delhi. The third one is Knowledge Park 3, Greater Noida. And the last one is Sector 125, Noida. Since we are doing the comparison between the ground and the satellite-based measurements or the satellite-based instruments, so here we have the list of the ground-based instruments. We have used the different types of the ground-based instruments, like the combined air sampler we have used, and there are the certain application. There are the specific application of each of the sampler we are using. For the combined sampler, it is having the application that simultaneously we can collect or we can monitor the PM2.5 and PM10 particles at the same time. And the respirable dust sampler, it has been used for monitoring the PM10 particles, and the gaseous pollutant sampler, it has been used to monitor the different gaseous pollutants like SOx, NOx, and ozone. For the fine particulate sampler, we use this sampler for PM2.5 sampling. Here, there is a pictorial representation of all the samplers we have used. Like all of you can see, the fine particulate sampler, respirable dust sampler, and gaseous pollutant sampler, and the last one is the combined air sampler. All of these are the samplers, are the instruments we use for the ground-based monitoring of the different particles from an ambient atmosphere. From the satellite measurements, you can see we have taken the different parameters from the satellite also. Like for the PM2.5, we have used the data source from the MERA-2 with a special resolution of 0.5 into 0.625 degrees, and the data was hourly based. And similarly for sulfur dioxide, nitrogen dioxide, ozone, we have used the data source was the ozone monitoring instrument with the same special resolution, that is 0.25 into 0.25 degrees. And the temporal data was on the daily basis. Here we have seen, you can see the different images from different locations. The first one is the sector 125, in that we are using the different kinds of the samplers for monitoring the PM2.5 and PM10. And it's the same, we are trying to show the internal structure of the different samplers. Here we can see the filter papers we are using. We have basically used the 2 types of the filter papers for the collection of the samples. For PM10, we have used the microfiber glass filter paper that's actually made up of the 100% borosilicate, and it's having the capacity of heat resistance of up to 500 degrees Celsius. And for PM2.5, we have used the PTFE that's made up of polytetrafluoroethylene, and the material is the Teflon. As you can see the difference between the before filtering, before sampling, and after sampling. How the filters were polluted after the sampling. Here we can see the variation in the PM2.5 concentration between the different satellites and ground-based measurements in all the 4 locations like Dwarka, Knowledge Park, Vivek Vihar, and Sector 125. For our knowledge, it was like for PM2.5 and PM10, the concentration of ground-based measurement, it was higher than the satellites. As you can see, the peak concentration here, we can see the peak concentrations was observed during the 8th to 14th of November, that's the week 6. And after the India's mega festival, Diwali actually, here we are seeing the burning of the firecrackers for celebration as well as the vehicular emissions throughout the festive season might be the reason for that. For the variation of the SO2 concentration, here you can see the satellite data was greater than the ground-based measurement. That has also recorded the peak values of the sulfur dioxide was between 15 to 21st of the November. That was the and that was particularly in the Knowledge Park 3. The peak value was there only.
Coming conclusion.
Yeah. Same is in case of the O3, ozone.
Yeah, directly coming conclusion.
Yeah. Here we have in the conclusion, we can see we have revealed significant variability of the different pollutants on the base of ground and satellite-based monitoring, as well as the values for the PM10 and 2.5 was higher than the daily limits that was prescribed by the National Ambient Air Quality Standards, and the highest concentration was seen in the month of November, indicating the influence of the Diwali festival as well as the emission of the other sources. And each pollutant shows the distinct trend, like with the winter having the highest concentration and the rest of the year seeing the lowest, especially for the PM 2.5 and PM 10. Despite this, there was the thermal inversion causing an increase in the concentration of the gaseous pollutants such as SO2, NO2, and O3. And although we have seen the concentration of the ambient air pollutants was significantly influenced by the meteorological variables also. Thank you.
Thank you. Any questions? There is no question. That is the thanks. We will move next presentation. Next presentation is by Mr. Rahul. He is going to present a modified pre-whitening method for train analysis in autocorrelated time series data. So Rahul, please before 10 minutes.
Hello everyone, myself Rahul and I am from Research Institute of Geological Science, and today I will talk about a modified pre-whitening method for trend analysis in a autocorrelated time series. So when we talk about trend analysis in hydrological or atmospheric application, so we talk about one of the most popular technique, man control test, that is based non-parametric test. We use to detect any monotonic upward and downward trend in a time series. So the advantages of this test is that it works on all type of distribution. That means if data is normally distributed, then if the data is not normally distributed, then it also works on that also. So it also can handle the missing data, and it doesn't affect by the outliers because it is a rank-based test, and if the magnitude, it doesn't matter the magnitude of outlier is low or high. So these are the advantages. So the disadvantage of this test is that it is not suitable for the shorter field. Means if there are 10 or 20 or 30 samples in the data sheet, then it won't give you the robust results. And it requires the serial independence in the data sheet. That means the data is not autocorrelated, but this is not usually the case in the atmospheric measurement, where the data is always positively autocorrelated with each other. So the serial portion is that means this is a big problem in our data set to detect the trend. So there are three main problems with the serial correlation. So first, if we detect the trend, that is increase the type 1 error. That means it will lead, if there is the reject, it means it will lead to the negative results. That means we give you the trend, but there is no trend, and it also overestimates the slope of trend. So how we can overcome this problem? So pre-whitening is the technique we use to remove this effect or account this serial correlation. So in the past, there are few pre-whitening schemes have been proposed. So first of all, the one proposed a simple pre-whitening scheme that simply remove the leg on autocorrelation. Here we are talking about only leg on autocorrelation. That means the correlation between two consecutive measurements. and we are not talking about any higher order of auto-collision. And after that, the second scheme was proposed by UE, trend-free pre-whitening scheme, and it works where it removes first the trend, then remove the leg-1 auto-collision, and then again that it adds the trend to remove the auto-collision from the data sheet. After that, one and Swell also proposed a pre-whitening scheme, and it is basically a iterative scheme, and also it include a correction factor to make consistent the slope of the trend with the actual data sheet. And after that, Wang in 2015 proposed a variation correction approach that account the increased variance in a automatic time series. So these are the advantages and disadvantages of these schemes. So first, the one-stroke scheme is a low type 1 error, low test power, and small absolute value. Actually, the problem is that these two errors, type 1 error or you can say type 2 error, it is not possible to minimize both the errors. We have to, if we trying to minimize one error, then it will lead to increase in type 2 error. So the aim is to basically minimize at the extent both the errors so we can get robust results. So after that, you also proposed and it yields basically high type 1 error, high test power, large absolute values. After that, one will propose that scheme. It will yield medium type 1 error, low type 2 errors, and the slope also increased by leg 1 autocorrection, by row 1, leg 1 autocorrection. Then after variation, one proposed this approach, and it basically is the low type 1 error, medium test power, and also estimate the slope to very similar to the actual slope. That way, it will give us the biased slope estimate. So in this work, I have proposed. So first of all, what I have done is that I have run this Monte Carlo simulation to check the performance of a new test that I have proposed in comparison of the previous pre-writing schemes. So we construct a autoregressive time series with the Lygon autocollision, and this is so you can say this is the AR1 series, and this is the effect of autocollision. This is the error, and this is the trend. Beta is the slope we have added to the time series, and we have generated this simulation. We have generated 5,000 time series of this AR1 process with mean we have taken 1 and the coefficient of variation, that means standard deviation 0.25, and we have generated a different sample size from 20 to 120 with a step size of 20, and we also taken different autocorrelations from 0 to 0.8 with a step size of 0.1, and including trend from low weak trend to higher trend from 0 to 0.01. So that's how we generated the time series to test or test the performance of new pre-writing scheme. And this is how we calculate the rejection rate. So basically, this is the spectrum, and N is basically the 5,000 times 5,000. And rejection is means how many times we reject a null hypothesis. That means there is no trend exists. We reject that hypothesis. This is the number. So this is how we have, yes, this is how we create this scheme. First, we check the effect of autocorrelation. We calculate like an autocorrelation with 95 confidence level. If there is no statistically significance of this correlation, then there is no need to apply this pre-writing scheme. But if there is a statistically significant autocorrelation, then we use these further steps. So first we first we remove the autocorrelation with this correction, with this correction term to maintain the slope with the original trend, and then after we apply this sense slope to calculate the slope with previous time series, and we remove the trend, and then we apply, we run this to step 2 and step 3 iteratively, and we until when we reach the difference between row 1 and that means level of collision, and the trend of 2 successive iterations become less than 0.00, and after we stop the iteration, and then we again correct the trend with the variance inflation factor that was proposed by Metcalfe. He gives the limiting value of variance inflation factor. So we corrected with this, and we again then add this corrected modified trend with this time series, and we get our final pre-widening time series that we will use to detect the trend and its measurement. So these are the results. First, the type 1 error. So you can see the original. These are the results. So you can see the our method is consistent with the level autocorrelation, and it won't. It will always lie in the critical region. And we also compare the root mean square error of the previous scheme that was proposed by one variance corrected approach and this new approach, and you can see the root mean square error is less from a low to high correlated tendency, but at a high correlation there is a significant rise in the root mean square error, and these are the trend estimations. So this is the trend we have put. We put in that AR1 series, and what we have get from the pre-writing scheme. So you can see for a low number of sample and the big trend, this method or any method is not performing well. But when you can see for high number of samples and a strong trend, and at a low population, so it gives a quite robust result and give nearly equal to the actual trend. And these are the power. This is the power of test, and you can see that power of test is again very low for low number of sample, and so for power of test, the scheme proposed by Wang and Swami is performing well as compared to our scheme and the also. But when you see that when the number of sample is quite enough, that means higher than 60 or 80, and the trend becomes large enough that it won't create a good, so it will give us a good result. And but again, the high correlation, autocorrelation, this has also deviates the actual results. So yeah, again, this is a control plot. You can see the results are quite good at high trend, strong trend, and a large number of samples. So this is my final slide conclusion. So the results are that the new method is a more accurate slope estimator with low error and compared to the VCTF. So we compare these results with this particular scheme because these schemes already claim that they have give unbiased slope estimation. So we compare our results with only this scheme, and we also the slope estimation of this new scheme is robust for lower to medium or autocorrelation, but it significantly deviates from original trend for high correlated time series. And when we talk about type 1 error, then it is more an acceptable result with better accuracy for all autocorrelation from low to high correlation as compared to TFW proposed by one mention. And when it comes to the power test, that means the type 2 error, then the new method is not suitable for the big trend and the low number sample, but it is quite very suitable for if the trend is very strong and the sample is large. So thank you.
Thank you, Rahul. Anyone to question? No question. Let's say thanks. Announcing one point.
Afternoon, everyone. You can all move towards the outside the auditorium for tea break, but please reassemble here after 15 minutes. Okay?
You take the tea and come inside. We'll continue the talk. So next talk is Manmathan Nayak. चाय लेके आप लोग अंदर आ जाइए, ताकि सेशन डिले ना हो बहुत ज्यादा। And the next talk after the terminal is Hisab आप मारे, you copy your slide here.
अरे आ जाओ काम तो होते रहेगा ध्यान रखो भी सही
So now we can start the talk. So the talk is by Mr. Mandal. He is talking about the variability of cloud-based height cover over tropical region in Pune. So Mandal, try to finish before 10 minutes.
Good afternoon, everyone. Myself, Runal Naik. I'm pursuing my master's in Savitribai Phule Pune University in Department of Atmospheric and Space Science. So I'm working on a project on a topic like variability of cloud-based height over the tropical region, that is Pune. So the basic introduction of the formation of cloud, that is homogeneous and heterogeneous formation at moving on towards the data and methodology. The data we have used is taken from the speedometer device. It has been installed in the university campus. The speedometer is the data which gives the height of cloud ceiling and a cloud thickness. It is a light type device. It uses the atmospheric radar instrument. It consists of a transmitter, receiver, and a data recorder. The transmitter emits a beam of wavelength of 908 nanometer, which has been scattered, and then it reaches the cloud base. Uh, the scattering beams from cloud is detected by the receiver. The it, the receiver is located at a fixed distance from the transmitter. It uses a photoelectric cell to detect the backscattering of the beam from the cloud. The ceilometer gives information about the cloud-based 1, cloud-based 2, cloud-based 3, as well as the penetration depth, cloud amount, total cloud coverage, and vertical visibility. So, for study, the data I have taken the data from March 2017 to July 2022, where the range of kilometer is, it can detect the cloud-based height up to the 7.5 kilometer, and the readings are it keeps reading up for each and every 30 seconds of interval. Then moving on the results, there is a variational for CB1 for seasonal variation for each season. So first moving with the winter, we have got that during winter it shows increasing trend from 00. It shows increasing trend from 00 UTC to up to 8 UTC, and then it shows a decreased trend for all years, but except for 2018 and 19 winter, we have not observed the same trend, but we have observed the increasing trend even after the 14 UTC as compared to all years. Whereas during pre-monsoon, the variability of CB1 shows a similar trend for all 5 years. That is the increasing trend up to the 11 UTC and slight decreasing trend, and again the increasing trend towards the 15 UTC. So for monsoon season, variation of cloud-based height during monsoon does not show any diurnal variation. It almost shows the same variation for day and night. But base height is maximum ranging up to 2 to 2,500 meters. Whereas for post-monsoon, the base height is shifting upwards for all the years. So it shows the increasing trend till 9 UTC, then a slight decrease in base, and then again the increasing base height. But for the base 2, there is intra-annual variability in base 2, that is from 3 to 10 UTC. It shows a higher, while for rest, the CV2 altitude is quite at lower height. And for pre-monsoon, CV2 height is from 2 to 11 UTC, then it decreases afterwards to lower altitude, whereas from 2 to 11 UTC it shows the increasing trend. For monsoon, CV2 also shows the intra-annual variability is very low, that CV2 fluctuates between 2 to just 3.5 kilometers height. There is similar trend followed by all years. But for post-monsoon, there is high intra-annual variability in CV2. That is between 5 to 12 and 19 to 22 UTC, the CV2 is higher. It shows the increasing trend. While for the while for the other time, the height variability is quite low. Then the frequency of occurrence for season has also been calculated. Then frequency for CP1 during winter shows for both CP1 and CP2 contribute equally, whereas CP2 slightly dominates during the mid-season, and again the CP1 is dominant towards the end of the season. Then for pre-monsoon, during the start of pre-monsoon, we can see that CP1 is dominating during 00 UTC and from 12 UTC to 19 UTC. But during the middle of the season, both CP1 and CP2 are giving equal contribution. Whereas towards the end of the season, we see that CP1 is slightly dominating the CP2.
Whereas for monsoon season, CB2, the contribution of days to height is dominating all of the season. And for post-monsoon season, initially CB2 seems to be dominating while during 15 UTC to 18 UTC we see CB1 is quite dominating the CB2. While during the end of the season, during 0 to 3 UTC, we see CB1 dominating, and even during 16 to 22 UTC, CB1 is dominating. But for the rest of the hours, we see CB2 is quite dominating the CB1 occurrence. Then coming to the summary of frequency of occurrence, we see that during winter, occurrence of CB1 and CB2 gives high contribution and almost they have equally contributed throughout the season. But during pre-monsoon season, CB1 is dominating for 0, 0 and 1 UTC and again from 12 to 19 UTC. But during middle of the season, both CB1 and CB2 give equal contribution, and during end of the season, we see slight domination of CB1. Then for monsoon, CB2 is dominating overall the throughout the season, and for post monsoon, during the post monsoon in initial phase, we see CB2 to be dominating, while CB1 is dominating during the middle, that is 12 to 18 UTC, and while end of the season again CB1 is dominating. So this So this is the actual image of how the cloud base is displayed on the data recorder. This is the altitude for which we can see at what height the cloud base is being detected. And this is the time in UTC.
Thank you. Any questions? I think there is no question. Let us say thanks.
Thank you.
And we can move next presentation by Nisa Wagmare.
Good afternoon, everyone. So my research in this conference is impact of lockdown on column and surface aerosol content over Ahmedabad and comparison it with Indo-Gangetic plains. So these are some aerosol details which are earlier explained already. Now, which period we are going to study is that COVID-19 period in Gujarat, over Gujarat, the lockdown was affected from 25th March to 31st May. Are we okay? Yes. 25th March to 31st May. Now, according to the relaxations, the lockdown was eradicated from Gujarat. Now, which data we have used? We have studied, this is a study area, we have studied the region, Gujarat region. In Gujarat region, we have studied Ahmedabad region. And IGP region, we have studied central IGP cities like Delhi, Lucknow, and Patna. From where we have taken our data is Modi's data of Gujarat, Ahmedabad, Delhi, Lucknow, Patna. And we have also taken PM data, Ahmedabad, Delhi, Lucknow, and Patna. And which phases I have considered? I have considered before 25th March, it was pre-lockdown. 25th March to 14 April, it was lockdown 1. 15 April to 3rd May, it was lockdown 2. And lockdown 3 was 4th May to 31st May. Now, before going for the comparison, I will show you some AOD values, how AOD values reacted during lockdown period over Gujarat and over Ahmedabad. Now, over Gujarat, as we can see that when we are taking climatic mean over Gujarat, it is like 90% AOD values are lower in March. Always, not always, but 90% AOD values are lower in March period. And the second graph shows that this is climatic mean, and red one is the AOD. We have taken this 2020 AOD. So we can see that after effecting lockdown, the AOD values are lowest. Here pre-lockdown, and this is after lockdown. This is over Ahmedabad. We have compared with 5 years. Now we can see that during 5 years, the variability and values of AOD are less in 2020 as compared to 5 years. And if we are taking climatic mean of that 5 years, we can see that AOD is low during first period, slightly high during lockdown 2 period, and after then it again becomes low during lockdown 3 period. This is also showing the same, that it is drastic change from climatic mean to this lockdown 1 period, then it is increased, then it is decreased and decreased. Now why it is increment in lockdown 2 period? That is the question. Now during lockdown 2 period, we have found the trajectory showing some marine influx from Arabian Sea. Because of that, one of the reasons that AOD is increased in during lockdown 2 period in the April in Gujarat region, Ahmedabad region. Now, this is comparison between Ahmedabad and IGP region. We can see that showing same. Every cities have shown reduction after lockdown. But what is interesting that Delhi, Lucknow, and Patna is showing more reduction because they have more pollution over there. So reduction will be obviously it will be high. This is some weekly changes. See, this AOD, this is a mean AOD at different stages of lockdown at different cities. Ahmedabad it almost remains same after lockdown, lockdown 1, lockdown 2, lockdown 3, during full lockdown. But see, as a relaxation is given, it is coming to the level to the PL pre-lockdown level in Delhi, Lucknow, and Patna. And I can say that after lockdown, it could be more than PL also in this IGP region. Now, what is the interesting thing? This variation of Armstrong exponent. Size, if we are seeing the size distribution, then according to this graph, we can see that in Ahmedabad region, AE increases, Armstrong exponent increases, which shows the size distribution of the aerosol. This we can say that over Ahmedabad region, the fine mode particles increases, the dominance of the fine mode particle increases. Now, but that is different for Delhi, Lucknow, and Patna. The AE decreases. We can say that the coarse mode particles dominance increases because of some lockdown effect. This is PM, variation of PM, particulate matter, PM 2.5 and PM 10, showing reduction, less variability in the data. Here also reduction, less variability in the data. PM, and as we have seen, we are justifying this A value which we have obtained before, that here A increases and here A decreases. We have justified that PM also remains almost constant over here, and PM increases with lockdown relaxation or given over Delhi, Lucknow, and Patna. See. Therefore, the partial relaxation offered in LD2 and LD3 did not affect aerosol content of Ahmedabad, but that resulted in more loading of anthropogenic aerosols over IGD, because as relaxation is given, so biomass burning and it started over that region. Here we have taken PM 2.5 by PM 10 ratio. This also says that the ratio is lower than that of the ratio is given. So ratio, we can see that almost ratio remains same over here, and here ratio decreases. So we can say that in Ahmedabad, no significant change in ratio with lockdown. It remained almost 0.4 throughout the study period. But in IGP, slight decrease in ratio with lockdown. At Delhi, this reduction continued in LD2. Reduction of this ratio during lockdown 1 at Patna is very significant, but it increased after that. So hence we can say that in general there was relative reduction in fine mode particles in comparison with coarse mode particles with lockdown over IGP, and AE values also reveal the same. So these are my conclusion. The reduction was seen everywhere. The reduction was more prominent in the IGP region as pollution was already high at that region. And A is PM 2.5 by PM 10 ratios remain same over Ahmedabad region, but PM 2.5 by PM 10 ratio increases as so we can decrease this in IGP region. So we can say that coarse mode particles increases over that region and fine mode particles dominant over Ahmedabad region. So with this much of lockdown, we can say that it gives us hint that if this much lockdown can affect to the pollution of air quality index over this all region, it is very effective. So it gives us hint that if we give some more efforts to the environment, so it will be more effective. Okay,
Thank you. Any questions? Yeah, I want to. So you are saying that during lockdown, Delhi, the post-mode aerosol is increasing. Your A is less, right?
Yes. Yes. The over IGP region.
Delhi is also IGP.
That,
why
yes.
why it is increasing post-mode? For Ahmedabad, you are saying the fine mode is increasing.
So the sources of apportionment at different cities are different. In Delhi it is increasing because biomass, but because of this effective in lockdown as effective. So coarse mode particles, fine mode particles decreased in Delhi because sources of aerosols at Delhi. Fine mode particles were sources of fine mode particles are vehicle industries and all. As lockdown was implemented, so the fine mode particles decreased and the coarse mode particles increased. In Ahmedabad region, fine mode particle increased because it was the influx of many disturbances like western disturbances during this season, March, April, and May. Western disturbances are so much prominent to this Gujarat. So transported aerosols comes over Gujarat, which leads to increment of the aerosol over that region.
Is there any rule of dust?
No, it is not. But we have just given a wind trajectory. If we want to try, we can go for the wind trajectories, and the wind trajectory will show from where not only the wind trajectory. There are many parameters we can say that. But I have taken that wind trajectory. It will show that aerosol might be transmitted from that region.
Anyway, thank you. Any other question? Okay, thank you. So now we have one more invited talk by Dr. Jessica Kunal. He is waiting this morning. So, Kunal ji?
Yes, yes. Mukaji, yes. Am I audible?
Kunal ji? Yes.
सुनाई दे रहे हैं? Am I audible?
Yes, yes, sir.
Okay.
So, Dr. Punyalji joined the GB Pant National Institute of Himalayan Environment in Kochi, Katalma, Almora as a scientist in November 1993. And then at present he is working as a scientist, senior scientist G, and head of the Environmental and Climate Change Center at the same institute. And he has published books and several papers in international reputed journals. And for his impressive work, he has been awarded by P.N. Mehra Young Scientist Award in 2005, then State Award from 2008, and Application Award in 2008, and recently his Lifetime Achievement Award in 2015. So I would like to invite Dr. Punyalji for a presentation. Punyalji?
Yeah.
Yeah, you can present.
Yeah. Doctor, screen is visible or not?
It's not visible.
Okay, I'm trying.
Yeah.
I'm trying.
Hello. Sir, your screen is visible. You can open the PPT now. Please share PPT only.
Do you have his PPT file? Sir, we can share from here.
Yeah, you please. Is it visible now?
Yeah, it's visible. You make it presentation mode.
Okay. But during presentation mode, it doesn't move. Please see, is it moving?
No, it's not presentation mode.
No, actually it is presentation mode. Otherwise, what you can do, you can share from there itself. If there is problem.
Yeah, okay, we will try from here. You can share from here?
Yes, sir.
Sir, are you able to see it? Hello? Kunyaji?
Yes. But the problem, Dumkaji, I am not in a position to see the letters, but I will keep on speaking. You just move on, please. Okay.
Okay, sir.
Hello.
Yes, sir.
Actually, what I will do, I will run from my presentation and just I will minimize this one.
Yeah.
And some technical persons will move on. I will say in between, please next.
Yeah, yes, sir. You can say next, we can move.
Okay.
Thank you, sir.
So please, you see that this is a very important what I should say conference that the organizers could provide me this opportunity, but due to some of the over-occupied or some engagements, I could not come or to the place in person. And the topic is black carbon aerosol optical bath and radiative forcing at Katarmal Almura. But here I have also tried to compare one of the important stations from Himachal Pradesh. Next, please. So, in our daily life, or especially when we talk about the Indian Himalayan region, then definitely the question arises why we are studying atmospheric pollution. So it is because that still in some of the parts of the Indian Himalayan region, nobody is going its exact status because in the atmosphere is a very dynamic one, and similarly the atmospheric pollutions have such kind of behavior. And with this, atmospheric behavior, dynamic behavior, or its concentration, so many uncertainties are still there. But this fact that with the increasing atmospheric pollution, there is a rise in temperature, and its effect is again seen in global warming, and ultimately that causes climate change. And as a result of that, you might have seen that shifting of crops, orchards, and vegetation to higher altitude from lower altitude. It is a very common feature now, and in some parts of the Indian Himalayan region, you might have seen. I always speak that the sun is same whether it was in the decades before or today, and but why this atmospheric temperature is going to rise, and this is the main cause that we are studying, or we say that aerosols, and its other impact is on health problems and respiratory problems. Next, please. As you see, my previous speakers, I have heard them, and they were talking about that it has a big respiratory problems in the human beings. You can see that our lungs are going to be, at risk when these smaller and smaller, to which we call ultrasound, ultra, but I should say size particles are entering into our lungs, and they say sometimes we call it innermost part alveoli. Another adverse impact of these pollutants has been observed on plant life also. So, for example, if suppose some of the leaves are going to turn into yellow, then it is primarily assumed that surface ozone concentrations are there above permissible limit. Next, please. As many of the speakers might have told you that aerosol size scientifically categorized in three categories: fine mode, accumulation mode, coarse mode. But here, if you see that fine mode size particles are supposed to be generated only because of anthropogenic impact in our atmosphere, while the coarse mode particles are supposed to be from natural sources only. You can see left and right down pictures. These are showing the pictures of aerosol sources. Here, next please. Here I have taken two study sites. One we have been measuring at Mohol in northwestern Himalaya, Himachal Pradesh, and the second study site is from 2018 at Kosi. And here also we have established at two sites environmental observatory where we are simultaneously measuring particulate pollution, aerosol optical depth, and black carbon aerosols and air chemical properties at Kosi Terminal Almora as well as in Himachal Pradesh, Mohol Kullu. And I'm next please. I'm very happy to tell you that these are the equipments through which we have measured our observation. Regarding, you can see on left northwest corner, that is accelerometer to measure the black carbon aerosols, which is known to be the heat absorbing aerosols. On right corner top, you can see multi-wavelength spectrometer. This is a program supported by Space Physics Laboratory, DSSC, ISRO, and it is a long science program to which we are, going to conduct at Mohol Kullu. And similarly, you can see the bottom of multi-wave meter is microtoxin photometer. On left is some pyranometer to measure, and along with this, we also need weather stations to analyze aerosol relations. When we are talking about next please, ambient air quality, you will see this variable dust sampler and the fine particulate sampler also, and this tells us what is the health of ambient environment. Under this we measure PM 2.5, PM 10, and even we have started to measure the PM 1. And based on mass, calculation, we are also using ion chromatograph that is still under installation at Koshikatarman Almora to see ionic component, but in Himachal Pradesh we have already analyzed these parameters. Next, please. You can see the behavior of aerosol optical depth. The highest one you will find in 2019, and lowest one you will find in August 2020. And maximum EOD at 500 nanometer was observed to be 0.64 in July 2019, while minimum was 0.17 in Feb. And EOD at 500 has increased during the 19 to 21, 0.31 to 0.43, that goes around 25%. If suppose next please, if suppose we see long-term data since 2007 to 2021, then you will see the through multi-wave interferometer you will find the fine mode particles below 500 nanometers are higher compared to the coarse particles. This indicates that there is a imbalance in our ecosystem because fine mode particles are supposed to be generated more compared to coarse particles. As I have already told, fine mode particles are supposed to become human interferences in our ecosystem. Next, please. Similarly, you can see the general behavior of morning and afternoon UV behavior and afternoon behavior of aerosols. Some in most of the locations again higher due to convective activity in our atmosphere. And the next, please. Annual variation in UD at higher altitude, just last village of Rohtang Pass in Himachal Pradesh is going to show that these higher locations are having also quite considerable aerosol optical depth at fine mode particles. You can see even on glaciers we have measured it. And if suppose we see the behavior or relationship between alpha and beta, alpha is supposed to be considered to indicate the fine mode particles, whereas the beta is a cumulative mode or cumulative aerosol loading in our system. Then you can see always this behavior is paradoxical or contrary to each other. If suppose we studied black carbon aerosols at Qatar this distinct location during forest fire days, you can see their concentration goes 3,189 plus minus 718 nanogram per cubic meter, while during non-forest days, you can see 903 plus minus 345 nanogram per cubic meter. This means that during forest fire days, our black carbon aerosols also increased to 4.5 times more. If suppose in different locations you see the behavior of black carbon from higher altitude to the lower altitude, next please, CCF mode, you will find that there is a bimodal peak in our system in during morning time as well as the evening time. The two regions are always given to this bimodal peak. One is in the morning times we use we cook or we warm up and we cook food or whatever our routine activities start. Regular influx also increases due to school children as well as commuters, and in the evening time the same thing happens when we return. But it's scientifically causes in the morning time the boundary layer comes down as compared to other times, and in the evening time when sun sets also the boundary layer goes down due to low temperature conditions. So this is the scientific reason. When we see annual variations in annually we see then winter months are having greater black carbon aerosols in the atmosphere at our location. Similarly, if suppose we next this, if suppose we analyze its sources, then we will find that fossil fuel burning contributing 73% as compared to 27% through biomass burning of the total black carbon contribution in our atmosphere. Next, please. If suppose we see the behavior of black carbon from glacier to the lower altitude, then I would say in Parvati Glacier we have measured it, and you will find that our glacier, Parvati Glacier, on average experience or have been monitored to 78 nanogram per cubic meter as compared to the lowest altitude in the valley 2,423. So this indicates that even the glaciers are not untouched due to these aerosol in our atmosphere. Similarly, percent change increase from forest fire to non-forest fire days are again we have seen that there is remarkable change in it. Because I am moving past next please. Status of particulate matter in pre and during lockdown period. I am just narrating the headings and you please see from there, and then you will be in a position to press the slide. During pre-lockdown period, you will see that maximum concentration of CST stood to be 109.6, whereas in during after lockdown period it increased. Similarly, next is rate and percentage for different periods at Koshi Kakarama Hulmora when we analyze, then you will find that during lockdown period there is a remarkable decrease in atmospheric pollutant. For example, I take example of PM10. It was decreased 31%. At the last column you can see, and when we see the I compare, it came down 48%. Even NO2 and gases pollutants also came down up to 50%. So similarly, if suppose yearly percent change next is yearly percent change at Kosi terminal is observed, I have seen that there is again a remarkable change in BC, NO2, SO2, and PM 2.5 and PM10. And this indicates direct impact of human interferences in the atmosphere. Next, please. If suppose I talk about air quality index, it is okay. And next, please. Long-term transportation, if suppose sometimes we also analyze some of the satellite imagery and we see that in our neighborhood, what have been the sources, if suppose local sources are not supposed to be dominated, then Calypso satellite tells that when our atmospheric pollutants in our system, our experimental sites were increased, then there was some of the plumes nearby regions which are next please, which are again transported from western disturbances, and those air masses are supposed to be coming over the desert or west regions from northwestern countries, you can see, and those also contribute to a pristine locations where we are located at Katarwal, fine particles as well as sometimes some gaseous pollutants from Indo-Gangetic plain. Next, please. Concentrated heated trajectory of BCF Mohol. Suppose we see that you can see that there are two sources contributing in black carbon aerosol. One is local sources, another is external sources. Through these trajectories, concentrated heated trajectory, we can analyze that local sources are having more contribution compared to the transported aerosols. In this way, if suppose next is aerosol radiative forcing at Kosi Sakarwan I thought, then you will see that our atmosphere is going to be warmer and it is around 40 watt per cubic meter, especially at Mohol, and whereas in Kosi Katarwal it is bit lower compared to Kulu Valley because tourism interferences are there. You would surprised to know that annual inflow of tourists are going above 20 lakh per annum. And here at Kosi Katarwal you can see that radiative forcing is lower compared to the Kulu Valley, and whereas the top of the atmosphere is again having warmer bit because of black carbon aerosol concentration within the atmosphere. The reason behind it. Next, please. If suppose aerosol radiative forcing on average, we see at two of the locations of Himachal Pradesh, Kohol and Kopi, and naturally you will see again our atmosphere is going to be heated up, and there is a radiative imbalance between surface where the cooling effect is there and the Mohol where the warm up effect within the atmosphere is there. As a result of that, you can see on the average, you can find that atmospheric next please aerosol radiative forcing April 2006 and December 10. You will see that atmosphere is going to warm up 19.4 watt per square kilometer, whereas the cooling effect as surface is minus 19.2 plus minus 2.1 plus minus 3.3. So with this, suppose we calculate the heating rate of the atmosphere, and it goes 0.54 Kelvin per day. The temperature is going to rise. So next, please, aerosol radiative forcing over India, and we two centers are supposed to be RT network, Mohol as well as Katarmal, and other stations as Aries, Dr. Dhumka and the team and other colleagues are doing. And in for the Indian Himalayan regions, we have also measurement centers. So based on this, I would say that if suppose, like next please, if suppose I take example on average, then 0.62 Kelvin per day temperature is going to rise because of aerosol rising per unit of rising And in summary, I will let you know that this is the conclusion summary part. Please next. Then it is a conclusion that two conclusions came wherever the anthropogenic pressure are higher, atmospheric pollutants are higher, but it is not always true. If suppose we have pristine atmosphere like Tatarmal, Kosi Tatarmal, then transported aerosols are contributing in it. So, as far as interferences are concerned, human and anthropogenic interferences are dominant in our ecosystem in Kullu Valley compared to the Katarmal situation at Almora in this location. So I would not take your much time. Thank you very much. If you have any queries next, please. Thank you. So this is the site in Kullu Valley where we have established our MWR. So with this, thank you very much, Dr. Chair, and our
Thank you, Priyalji. Thank you.
Thank you very much.
Any questions?
I don't know whatever you have got or not, but I rushed and because of time limit, and I don't know whether you could be able to see the presentation or not. But thank you very much. But if you have any query, please let me know.
Any question? One question? Yeah. कुनियाल जी क्वेश्चन है
जी बोलिए
कुनियाल साहब नमस्कार
Actually, there is a echo. There is a echo. Yeah, please. Even then, I will try.
कुनियाल साहब नमस्कार
Namaste, namaste.
नाइस प्रेजेंटेशन सर मैंने
Your voice is very low. Please.
सब प्रेजेंटेशन देखा कि आप सिर्फ वेरिएबिलिटी दिखा रहे हैं कि एवरी ईयर ट्रेंड बढ़ रहा है डिफरेंट लोकेशन से डिफरेंसेस दिखाए हैं पर डे जो है हीटिंग रेट जो है बहुत ज्यादा है ओवरऑल ये जानना चाहते हैं कि ब्लैक कार्बन की मिटिगेशन के लिए क्या एक्शन प्लान आपके डिपार्टमेंट से हो रहा है या गवर्नमेंट ऑफ इंडिया को आपने क्या एक्शन प्लान दिया है इसको मिटिगेशन के लिए
देखिए हमने जो है adaptation communication I have been in that part and we have developed a document for AC was coordinating and MOE is supposed to be sponsored. So within that, these all aspects have been covered. If suppose that got published, then you would be in a position. But as far as heating rate are concerned, you see, in the Kullu Valley, almost 20 to 30 lakh tourists are visiting. And nowadays, you will see that only because of this concern, Honorable National Green Tribunal has taken so many steps. And we have been given this assignment to prepare the report how these pollutions, especially in certain locations, could be minimized. So we have also assigned this task to prepare the environment plans of Uttarakhand government, district environment plans, and if you are interested or any audience is interested, they can go on website of the State Pollution Control Board, Dehradun, and those are really downloadable. And now we are in finalization position that I can say, and you please go that document, then you will come to know what measures are to be taken. But for me, we need to reduce the anthropogenic pressure in our ecosystem, and we need to cultivate the indigenous species which are supportive to absorb gaseous pollutant, and then we can have a green belt concept wherever we live. So this is the ultimate solution, and we need a rich, biodiversity. This is the solution of
my question
air
is
pollution,
different.
what we call.
Hello, Punyal sir, you are the advisor. My question is different. Totally different. Actually, you are telling that tourist is every year increasing. तो पोल्यूशन तो बढ़ेगा बढ़ेगा उसको मेरा कहने का मतलब इंक्रीजिंग ट्रेंड दिखाने से हमने जो आप ईयरली उसको हीटिंग रेट को मल्टीप्लाई के लिए तो एकदम जलने लगेगा पूरा हिमालय क्वेश्चन ये है कि इसके लिए एक्शन प्लान क्या है आपके पास
सुरेश तिवारी ना डॉक्टर तिवारी
यस
ओके If your aerosol optical depth is increasing, definitely your heating rate will be increased. And
एरोसोल इज डिफरेंट थिंग से कोर्स मोड पाइप होगा तो ही वो हायर होता जाएगा एरोसोल इज डिफरेंट थिंग discussing about the black carbon. Okay, thank you very much, we will discuss later.
Thank you, Gandhi. Thank you for a nice presentation.
You see, biomass burning is another problem. Biomass burning is another problem in the region. Even suppose we have CNG and we are using gas. But in rural area, the people are not accustomed to use this, LPG even in winter season. You might have seen. So this is a, this is not a single factor contributing to it. Rather, it is a complex of factors.
Sir, we can discuss later on details. Thank you, sir. Thank you. So,
thank you, Dunkaji and Professor Tiwari. Thank you very much.
Yes, sir. Thank you. So, there is some delay in the lunch, so we can have one quick invited talk by Professor Ramesh Chandra. And after that, Dr. Swami, we should be ready. And after lunch. So, basically, Ramesh Chandra did his MSc from Swami University in Nainital. Then he joined as a scientific officer in Aries, Nainital, and he did his PhD from Aries itself. Then he moved in, he did his postdoc from France, and then he joined the associate professor at DSB campus, Swami University in Nainital. Now he as a professor, working as a professor there. His research area is basically solar physics, coronal mass ejection, solar flare, etc. And he has published around 100 papers in international reputed journal. And along with this, he is member in different societies like as a member in International Astronomical Union, member in ASI Astronomical Society of India, Royal Astronomical Society. So I would like to invite Professor Ramesh to present his talk. So Ramesh, please finish in 10 minutes. Only 10 minutes you have.
Hello, good afternoon to all of you. So maybe I am talking a little bit different because from the beginning we all are in the atmospheric physics. So maybe it is a bit different. So I will talk about the large scale solar eruption. What are the large scale solar eruptions? Yeah, so this is just the outline. First, I will discuss a little introduction, and then I will talk about what are the large and small scale eruptions, and then what are the possible models, and what can be the future prospects which can be useful for the young master students. Next. No. So this is the introduction part. So when we start from the sun, the energy is generated in the core of the sun, where with the high temperature and pressure, and the transportation is up to 0.7 solar radii by the radiating process. Then we have the convection process, and then this is one of the schematic for the solar structure. And then initially we assume there is a colloidal magnetic field. So due to the differential rotation, because sun it is a gaseous body, so it rotates differentially. So due to the differential rotation, we can see the formation of sunspots. So this is just like by the differential rotation, and then this toroidal fields rises to surface due to magnetic buoyancy, and we can see the sunspots. And these are the example of active and quiet sun. So in the active sun, we have large concentration of magnetic field, localized concentration of magnetic field. As you can see the bright area in the left figure, this is the image of EUV image observed from space. And these bright areas are the active regions.
and the right side we can see there is no bright region, so there is no active region. So this is the image during the solar maximum, and this is the image during the solar minimum. And the activity can be divided into two categories, as I already told. So this is the small scale, and in the small scale activities, we have pre-flare brightening, surges, alarm bombs, umbral dots, and solar jets. And for the large scale eruptions, basically these are the filament eruptions, solar flares, and coronal mass ejections, and the UV wave. These large scale eruptions are responsible for our what we call sun climbing, or we can say the space weather. And this is just an example. We have these are the pre-flare brightening, small scale eruptions. So in the pre-flare brightening, we can see before the big flare, we have the small brightening. So they act like a precursor phase. And these are the alarm bombs. So in H-alpha line, this is 656, 3 angstrom. We can see some bright regions, and these are known as the umbra. These are known as the alarm bombs. And this is the sunspot. So in the sunspot, in between we have some bright dots, and these are known as the umbral dots. And another important small scale events are the solar jets. So these are the defined as sharp-edged polymetallic plasma ejections with a very fast speed. So we can see if we compare the small scale. So I just compare here is the scale of the size of the small scale event. So you can see one of the example of the solar jets seen in different wavelengths. And if you compare the size of the Earth, so the small scale eruptions are like the size of the Earth. And if we go for this is another example of the small scale. So you can see the eruption of solar jet. So we have the recurrent jets going here in some small interval of time. So I will skip it. And then we have this is another example of this is the example of the large scale eruption. So in large scale eruptions, we see initially we have the initially we have the filament, and then you see the way when the filament is erupting, we see the explosion of the energy here, and this is known as the solar flare. And this is another example of the large scale eruptions where that is we call the EUV wave because of its observation initially in EUV extreme ultraviolet wavelength, and this we call also the solar tsunami because it is observed or it holds the solar disk if you look from here. And then these are the coronal mass ejections associated with that filament eruption. And this, instead of that, we have also observed the failed eruptions. So there are the cases reported where this filament is going up, then again it's coming down. So such eruptions are known as failed eruptions, and these are not responsible for the space weather disturbances. So this is just the summary. So solar eruptions, the filament prominence eruption, flare, CME, jets, and these all are the eruptions. And different observational manifestations. So these are the different observational manifestation of the same physical phenomena, that is the disruption of coronal magnetic field. These phenomena occurring together appear to depend mainly on details of the pre-eruption magnetic configuration. Cases in which the eruption does not evolve, as we already see in one of the movies, these are known as failed eruptions. And to explain these phenomena, there is a model proposed, the CSSCOB model. According to this model, when there is eruption of the filament is basically the cool material suspended in the corona. When it is erupting, then there is some magnetic reconnection process here. So due to this magnetic reconnection process, here the particles are accelerated, and due to this acceleration, due to the gyrosynchrotron radiation, they come along the magnetic field line and hit into the solar chromosphere or solar surface, and finally we can observe it in the form of solar flares.
And this is the another view. It is the 3D of this standard model, where we can explain the solar eruptions by this standard model. But the question is that how it is triggered, because the eruption model is mainly about when the eruption starts. So these are the possible trigger mechanism. So one is tether cutting, another is breakout, magnetic breakout, and the last one is catastrophic loss of equilibrium. So in the tether cutting model, we have the filament material here, and the field line are, if you look, are connecting. Some field line are from here to here, another are here to here. So it connects two sets of field line. When there is some instability due to the filament, due to the polarity, magnetic polarity movement, this filament can disturb and they can reconnect. And due to this reconnection, we have this eruption. So that is the one of the possible model for the solar trigger. And these are the observational evidence of that model. And another model is known as the magnetic breakout model. In this magnetic breakout model, the reconnection is above the filament. In the tether cutting, it was below the filament. But in magnetic breakout model, the reconnection is above the filament. So when there is the reconnection above the filament, then field line breaks and reconnect. And as a result of that, we have less magnetic tension. So due to less magnetic tension, this part will go out and observe as a coronal mass ejection. And another most accepted model is that now it is the basic idea in this catastrophic loss of equilibrium is that since the photospheric flux distribution, magnetic flux distribution, does not significantly change during the eruption process, so it is believed the eruption is produced by long phase. During this magnetic field is stressed and free magnetic energy builds up, and the configuration grows quasi-statistically. And if the coordinate field reaches in some threshold above which the balance between magnetic pressure, because magnetic pressure is working outward, and magnetic tension is working inward. So when this balance is disturbed and the eruption starts. And apart from the short-term activity, there are also long-term activity. So according to this long-term activity, we have 11-year cycle. So the features are also the 11-year cycle. So if you look at the plagate and these features, all these shows the 11-year cycle activity. And these are some of the examples, some of the features where we can see the 11-year activity. So this is the data from the Kodaikanal Observatory. It is almost about the 100-year data. So we can see the evolution with the different latitude belts of solar atmosphere and how it is changing with the different latitudes. And at last, I would just like to show this picture where we can see that this is the evolution of the solar cycle. So when I call solar cycle, so this is the sunspot, maybe sunspot, and it can be solar flare index, some index defined for the solar flare, and maybe some radio flux. And if you compare it with the solar irradiance, so the solar irradiance also follow the solar cycle evolution. So if for the atmospheric point of view, if we are looking for the long-term activity in the atmosphere, so I think we need to remove this solar cycle phenomena from the data what we are analyzing. So maybe I should stop here. So these are just the future perspectives. So this may be important that the main topics they come from the observation. So how new magnetic flux is emerging, how dispersing the flux and build up this one, and why magnetic contribution error. It's still open questions, and we have plenty of space data which is easily available, free of very easily available. So we have a lot of scope to look in these fields. So thank you.
Thank you, Professor Ramesh. Any questions? I think there is no question. Let us say thanks to Professor Ramesh.
Okay, thank you.
So I will hand over to organizer.
Thank you so much. I would like to call upon Professor Suresh Tiwari, Professor Atul Srivastava, and Professor Pallavi Saxena to give a token of appreciation to the invited speaker and our chairperson. Dumka sir. I would like to call Dumka sir.
एक्चुअली बहुत अच्छी तरह से यह सेशन जो है दुमका साहब उसको निभाए हैं, इसके लिए बधाई के पात्र हैं। दूसरा, मैं यंग लोग जितने भी हैं जो प्रेजेंटेशन किए हैं बहुत ही बढ़िया था, लेकिन एक मेरा सुझाव है, जो भी सुपरवाइजर हैं उनसे सिर्फ डाटा कलेक्ट करके कंपैरिजन करने तक नहीं करने का, उससे बढ़ करके कुछ एडवांस जो है कुछ नया साइंस निकालने की कोशिश करिएगा। इसलिए कि जैसे आपके सामने मैंने पूछा कुनियाल साहब से, वो एडवाइजर हैं, सिर्फ डाटा का कलेक्शन करके उसके बावजूद उसकी दिखाएं कि 10% 5% हो रहा है, तो आप स्टूडेंट भी ऐसा न करें, कुछ नया साइंस निकालने की कोशिश करें जो कि अब तक न हुआ हो। न्यू साइंस स्टडी करने की कोशिश करिए। उनका साहब ने एक बार एक बच्चे के बारे में बाहर बताया, जैसे जो है किस लेवल का डाटा कलेक्ट करें, कैसे करें, किस तरह से उसको सुझाव, तो कुछ नए तरीके कुछ सीनियर से सीख करके कुछ नई चीजें डेवलप करने की कोशिश करिएगा। हम आपको यह संदेश देते हैं, दुमका साहब के इस कार्य के लिए बधाई देते हैं। थैंक यू।
दुमका सर ने काफी लंबा सेशन किया है, तो एक बार उनको तालियां हो। और इसी के साथ ब्रेक अनाउंस होता है, और इट्स 2:20 40 मिनट्स का लंच ब्रेक, एंड आफ्टर 3 वी विल कनेक्ट अगेन फॉर द नेक्स्ट टेक्निकल सेशन। 2:20 मिनट्स ब्रेक। 3 पे आप लोग सब लोग यहाँ पे कलेक्ट हो जाए। थैंक यू। हेलो।